Good evening, sir.
Very good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir. Yes, good evening, friends.
Good evening, sir.
Yes, everyone are there. Can we start?
Yes, sir.
But sir, today's session is private anyway.
Okay, fine. So we'll start. So in the previous two sessions, we have discussed statistics, logical reasoning, and we had started with mathematics, right? So in today's session, we'll go in depth with mathematics. And having said that, the objective of these sessions are to ensure that we are getting at least 16 these subjects. So our objective is not to go in depth with all concepts in mathematics. Okay, so those concepts where we can score marks, we'll focus there. And certain concepts, yes, we'll have a touching reference where we can build upon during the preparation time, right? So at the end of the day, each one of us will ensure that we are scoring that minimum required marks in this subject. Okay, so in the previous class, we started with the first chapter, right? Ratio, proportion, and indices we had discussed. The last part of that chapter, logarithms, is pending. We'll discuss that and we'll solve some questions here. Now, as I said, that we'll be focusing on those topics where we can score more marks. So the first half of this session, we'll be discussing the first chapter and time value of money. Okay, ratio, proportion, indices, logarithm, and time value of money. They are reasonably easy, right? We have to just get the concepts right. And from these two chapters, 20 questions will be there. 20 questions would be there. So 20 marks will be in our pockets. And it's easy. We can easily score 15 out of those 20. Okay. So we'll start with logarithms. Okay. So when we say 2 to the power of 3 in indices we discussed, when we say 2 to the power of 3, it's easy for us. It's easy to calculate 8. But when we say 2 to the power of 102, so unless we have scientific calculator, it becomes difficult to calculate, right? So for that, logarithms came into picture. The concept of logarithms came into picture. So how does logarithms help us? It's converting bigger data into smaller data of different form. In statistics, we had discussed arithmetic mean. We have a shortcut method in arithmetic mean, right? Where we take an assumed mean and convert all the values into smaller values so that we can easily calculate arithmetic mean. So similar to that, so let's say 2 to the power of 3 is 8. We convert this 2 to the power of 3 is equal to 8 into a logarithmic manner. How do we convert it? Log 8 is equal to 3 when the base is 2. Log 8 to the base 2 is equal to 3. So if I want to convert it back to the other number, we call it anti-log, correct? Anti-logarithms. So again, 2 to the power of 3 is equal to 8. Base index is equal to the required number. So that is logarithms. So here we are, okay, fine. So log 102 to the base 2, how do we get this? With the help of logarithmic tables. There are values defined for every value of logarithm, and based on that, we can, by referring logarithm tables, we can get the answers. In examination, with regard to logarithm problems, they themselves will give you the log values. So we need not refer the log tables, etc. here. In the question itself, they will specify the log values. So we need not bother about it. Okay. So some of the properties that we have to remember in this particular topic, some of the properties. Two equations, okay, a to the power of x is equal to n, x is equal to log n to the base a are only transformations. So these both are same, but represented in different forms. That's all, right? Logarithm of 1 to any base will always be 0. So logarithm of 5 to the base, logarithm of 1 to the base 5, logarithm of 1 to the base 10, always it will be equal to 0. Why? Because anything to the power of 0 is 1, right? Anything to the power of 0 is 1. So this will always be in the base. This is the final answer, and this is the logarithm value. So logarithm to the 1, logarithm of 1 to the base, to any base, will be equal to 0. And logarithm of the same number with the same base will always be equal to 1. Why? Any number to the power of 1 will be equal to the same number. Right? 5 to the power of 1 is equal to 5. Therefore, log 5 to the base 5 will be equal to 1. So any number to the same base will be equal to 1. Logarithm to 1 to any base will be equal to 0. Then some fundamental principles. Logarithm of mn to the base a will be equal to log m plus log n. Log m plus log n. Log mn is log m plus log n. Similarly, log m divided by n is log m minus log n. Log m minus log n. And log of 1 divided by n can also be written as minus log n. Log of 1 by n can be written as minus log n. Now, can we change the base in the logarithm? The answer is yes, we can. Right? So when we are changing the base, log m to the base a can be changed using the principle log m to the base b into log b to the base a. Or log m to the base b is equal to the changed base log m to the base a divided by log b to the base a. Right? Don't worry about the derivations here. Just focus on these principles. The law that is there, the principles, the definitions, these are the things that we have to focus on. And as I said, how do we get the values in logarithm? Using logarithm tables. So here they divide the logarithm number into two parts. One is characteristic, second one is mantissa. Right? So characteristic is identified based on based on inspection of the number, given number, whereas mantissa would be derived based on or obtained from logarithmic tables. Now, how do we obtain the characteristic? Characteristic would be obtained based on the given number, the number of digits before the decimals, number of digits before the decimals, minus 1. If the number is greater than 0, characteristic of logarithm of any number greater than 1 is positive and is 1 less than the number of digits. So if the number that we have, if I want logarithm of 2, 3, 4, 5, what would be my characteristic?
3.
My characteristic would be 3. Why? Because 4 digits minus 1. Right? 4 digits minus 1. Similarly, logarithm of 37 would be characteristic of 37. 1, because we have 2 digits minus 1. 2 digits minus 1. But if the number is less than 1, 0.33, if it is less than 1, then the characteristic would be negative. Then the characteristic would be negative, plus we have to add one more number than the zeros to the right of the decimal point. So if it is 0.33, logarithm of 0.33, characteristic would be negative. What is the number of zeros that are there after the decimal point? 0 zeros. So add 1 to it, minus 1 would be the characteristic. If I want 0.00333 in logarithm of this number, what would be my characteristic? Characteristic would be negative, and number of zeros after the decimal point is 2. So characteristic would be plus 1
minus
3. Correct? That is how we get the characteristic. If it is greater than 1, whatever number of digits that we have, minus 1 would be my characteristic. If the number is less than 1, that is if it is in decimals, in such cases we have to count the number of zeros which are there after the decimals, add 1 to it and represent that number with negative sign. That would be the characteristic. Is that clear? Yes. And log 1 will be 0, log 10 is 1, log 100 is 2, log 1000 is 3, because these zeros, log 1 will always be 0, and these are just the extension of the number, and hence we have to just get the characteristic. The mantissa would not be there. Mantissa would always be the decimals. So if we say 4594 is the number on which we have to get the logarithm, what is the characteristic here? What is is it
3.
greater than 1?
3.
Yes, the number is greater than 1. So we have to go with counting the number of digits. 4 minus 1, 3 is the logarithm characteristic point. Now in the logarithm table, we are not worried about that here. In the logarithm table, this is the value that we get for that particular number. So 6623 is the mantissa. So 3.6623 would be the logarithm value of 4594. So if the number is 459.4, then before the decimals we have 3 digits. So 2 would be the characteristic. 4594 mantissa is 6623. So 2.6623. Similarly, 45.94 is the number. So two digits are there before the decimals. Therefore, characteristic is 1. If it is 4.594, only one digit is there before the decimal, characteristic is 0. If it is 0.4594, since none of the digits are there before the decimal, we have to write it in negative, and 0 digits after the decimal. The number of zeros are 0 after the decimal. Therefore, minus 1. Minus 1.6623. This is how the logarithm values are represented. Now, as I discussed, we know that in this case, logarithm of 4.594 is 0.6623, right? In this table we have seen. If I want the reverse of it, we call it anti-logarithm. Anti-logarithm. If x is the logarithm of a given number n with a given base, then n is called the anti-logarithm of x to that base. So in our example, we said 2 to the power of 3 is 8. So how do we represent it in terms of log? Log 8 to the base 2 is 3. Alternatively, what is anti-log of 3?
8.
8. What is anti-log of 3? 8. Correct? Anti-log of 3 is 8. The reverse. So log n to the base a is x, then n is the anti-log of x. Okay, so some relationship that we have already discussed. Log mn is log m plus log n. Log m to the power of n is n into log m. So log m to the power of n will be, push this n outside, n into logarithm of m. Log m to the power of n is n into log of m, and logarithm of a to the base b into, it's not plus, into logarithm of b to the base a is equal to 1. Logarithm of a to the base b into logarithm of b to the base a is equal to 1. So these are the concepts that we have to look into in logarithms. Okay, the main properties that we have discussed, based on these properties, questions will be asked in this discussion. Clear? Any doubts in this? So can we look into some questions then?
Yes.
Yes.
Yes. Okay, first question. Find the value of log 10, root of 25 to the base 10 minus log 2 cube to the base 10 plus log 4 square to the base 10, based on the properties that we have discussed.
One.
We get 1. Yes. How did we get this? Root of 25 is 5. Correct? So we get log 5 to the base 10 minus log 8 to the base 10 plus log 16 to the base 10. Now we know log m plus log n is log mn. And we know log m minus log n is log m divided by n. So applying those two principles, it is log 5 into 16 divided by 8 to the base 10, because log 5 plus log 16 would be log 5 into 16. Log 5 minus log 8 would be log 5 divided by 8. So 5 into 16 divided by 8, 5 ones are, 5 twos are. So 5 twos are is 10. Log 10 to the base 10 will always be equal to 1, because we had discussed log of a to the base a is 1. Therefore, the answer is 1. So we have to apply the properties. The 3 properties we have applied here. Next one. A is to b is 2 is to 5. Then 10a plus 3b is to 5a plus 2b will be equal to. This is simple. Ratios.
7 is to
7 is to 4.
7 is to 4. Yes. So simple. So 10a plus 3b will be, a is 2. So 10a is 20. B is 5. So 3b is 15. 5 threes are. Is to 5a, a is 2, 5 2s are 10, 2b, b is 5, 2b is 10, 5 2s are. So 20 plus 15 is 35, 10 plus 10 is 20. Simplifying this, we get 7:4. So 7:4 is the answer. Next one. The ratio compounded of 4:5 and subduplicate of a:9 is 8:15. The value of a.
4.
4.
Yes. 4. This is simple. Compounding means what? Two ratios multiplying with each other, right? So 4:5 and subduplicate of a:9 is
Root
Root
A.
A by 3.
root a:3. Yeah, root a by 3 or root a:3. So this we get 4 into root a is to 15. This will be equal to 8:15. How did we get 4 into root a? 5 into 3. Compounding, we are multiplying. So 4 into root a is to 15 is 8:15. Therefore, can we say 4 root a is 8? Or 4 ones are 4 twos are root a is 8. So root a is 2. Therefore, a is 4.
4.
A is 4. Simple. Then, if 1/2, 1/3, 1/5, and 1/x are in proportion, what is the value of x? Simple. Proportion, application of concept.
Fifteen by 2.
15/2. Yes. So they are saying 1/2 is to 1/3 as to 1/5 is to 1/x. So how do we get this? Cross multiply. 1/2 into 1/x is 1/3 into 1/5. Correct? So 1/2x is 1/15. Alternatively, if I rearrange it, 2x is equal to 15. Therefore, x is 15/2. 15/2. Next one. This is a little tricky. P is equal to x to the power of 1/3 plus x to the power of minus 1/3. Find the value of 3p cube minus 9p.
X plus 1 by x.
X plus
1 by x.
no. Okay, we'll discuss. So what is the question? P, they have given us P is x to the power of 1/3 plus x to the power of minus 1/3. They're asking us to find out what? 3p cube minus 9p. Right? This 3p cube minus 9p, before looking into this, yeah, alternatively, I can say if I bring 3 outside common, it will be p cube minus 3p. Right? P cube minus 3p. Now I know p. Can I calculate p cube?
Yes.
Yes.
Yes,
What
sir.
is p cube? X to the power of 1/3 plus x to the power of minus 1/3 whole cube. So this is in the form of
A plus
A plus B whole cube.
a plus b whole cube. What is the formula?
A cube plus
cube
B
plus
cube plus 3AB into A.
plus 3AB into A plus B.
Yes, a cube plus b cube plus 3ab into a plus b. Apply the same here. X to the power of 1/3 cube, x to the power of minus 1/3 cube, a cube plus b cube, plus 3 into x to the power of 1/3 x to the power of minus 1 by 3, 3ab into x to the power of 1 by 3 plus x to the power of minus 1 by 3, a plus b. Right? Now, further simplifying this, x to the power of 1 by 3 into 3 is x. 3 gets knocked off. 3 gets knocked off. So this is x. This is x to the power of minus 1 plus, again here, x to the power of 1 by 3 into x to the power of minus 1 by 3 is x to the power of 1 by 3 plus of minus 1 by 3, which is x to the power of 0, which is 1. So 3 into x to the power of 1 by 3 plus x to the power of minus 1 by 3. This one, what is there in the bracket, right? So this is p cube. This is p cube. Now, what we required was p cube minus 3p. So can I say p cube minus 3p is x plus x to the power of minus 1 plus 3 into x to the power of 1 by 3 plus x to the power of minus 1 by 3. This is p cube minus 3 times p. P is x to the power of 1 by 3 plus x to the power of minus 1 by 3. 3p, 3 into p. P is what is given.
They get
Now,
cancelled.
3x to the power of 1 by 3 plus x to the power of minus 1 by 3 and minus 3 into x to the power of 1 by 3 plus x to the power of minus 1 by 3 can be cancelled. Thereby, we get p cube minus 3p as x plus 1 by x. But what we required was not p cube minus 3p. We required was 3 into p cube minus 3p. Therefore, what is 3 into p cube minus 3p? 3 into
x
x
plus
plus 1 by x.
1 by x.
3 into x plus 1 by x. Now, if we look into the options, none of the options has this answer. Okay. But this has two brackets. So I think there is a printing mistake here. There should be 3 here. 3 into x plus 1 by x. This should be the answer. But ultimately, answer is 3 into x plus 1 by x. Whatever options that we have. Okay. Do we want to write this down or it's fine? Can we move on to the next question? Done?
Yes.
Okay. Okay, next question. Fourth proportion to x, 2x, x plus 1. Simple.
2x plus 1.
Yes. How did we get? We have to just cross multiply, right? X is to 2x. X plus 1 is to what? How do we get this? X into k, we'll say that unknown as k, will be equal to 2x into x plus 1, cross multiplication. So x into k is equal to
X square.
or r, yeah, correct. Instead of further multiplying it, we'll send k the other side, sorry, x the other side. K will be equal to 2x into x plus 1 divided by x. X and x will get knocked off. So k is 2x plus 2.
Plus 2.
2x plus 2. Okay, next one. The value of 3 to the power of n plus 1 plus 3 to the power of n divided by 3 to the power of n plus 3 minus 3 to the power of n plus 1. Okay, it's simple. It's actually simple. It's not hyphen unlike the problem before that we did. It's very simple. It looks a little complicated. We have to take something as common. That is the hint.
One by 6.
1 by?
1 by 6.
Very good. Excellent. Yes, 1 by 6 is the answer. How did we get that? 3 to the power of n plus 1 can be written as 3 to the power of n and 3 to the power of 1 into 3 to the power of 1 rather. 3 to the power of n into 3 to the power of 1 plus 3 to the power of n divided by 3 to the power of n plus 3 can be written as 3 to the power of n into 3 cube plus, sorry, minus 3 to the power of n plus 1 again can be written as 3 to the power of n, 1 in n into 3 to the power of 1. Now in all terms, we have 3 to the power of n. So we can take 3 to the power of n as common. If I take 3 to the power of n as common in the numerator, I'll be left with 3 plus 1. And in the denominator, if I take 3 to the power of n as common, I'll get 3 cube minus 3. Right? 3 to the power of n, 3 to the power of n get knocked off. 3 plus 1 is 4. 3 cube is 27. 27 minus 3 is 24. Further simplifying this, 1 by 6. Okay, so 1/6 is the answer. Then next one, value of x square minus y minus z square plus x plus z square minus y square plus y square minus x minus z square divided by x plus y square minus z square plus z square minus x minus y square plus y plus z square minus x square. Again, simple.
Click.
Yes, we have to just apply that one particular property that we have discussed, that we already know with regard to equations. What is that property? All these are in which form?
A square minus B.
Correct. A square minus B square. So what is A square minus B square? It can alternatively be written as
A minus B.
yes, A plus B into A minus B. Just represent all these in the format of A plus B into A minus B, you'll get the answer. X square minus y minus z square is x plus y minus z a plus b into x minus y plus z a minus b divided by x plus z plus y into x plus z minus y plus y plus x minus z into y minus x plus z divided by x plus y plus z into x plus y minus z plus z plus x minus y into z minus x plus y divided by y plus z plus x into y plus z minus x. Yes. So once we have this, we will have in each of the terms, we will have one in the numerator and denominator which can be knocked off. X plus z minus y can be knocked off against x plus z minus y. So this can be knocked off. Similarly, second one, x plus y minus z, x plus y minus z. This can be knocked off. Similarly, y plus z minus x, y plus z minus x. Right? Then we will be left with x plus y minus z divided by x plus y plus z plus y minus x plus z divided by x plus y plus z plus z plus x minus y divided by x plus y plus z. So if we take x plus y plus z as the LCM, then x plus y minus z plus y minus x plus z plus z plus x minus y. Add all this. Now, x and minus x, y and minus y, z and minus z. Now, what would remain in the numerator?
X plus y plus z.
Yes, x plus y plus z. So, x plus y plus z in the numerator, x plus y plus z in the denominator. The answer is 1. Simple. Right? So we have to just link those properties. We have to identify in which format it is. If you identify, then this problem is very simple. Next one. If ABC is 2, then the value of 1 divided by 1 plus a plus 2b to the power of minus 1 plus 1 divided by 1 plus 1 by 2b plus c to the power of minus 1 plus 1 divided by 1 plus c plus a to the power of minus 1. Again, The first step is a little tricky. If we get that first step, then nothing is there in this problem.
Sir,
Sorry?
sir, I had a doubt regarding the previous problem.
Yes, yes, yes.
Sir, if we substitute x, y, and z, we give some values, say 1, 2, and 3, then also it should satisfy, no, sir?
Correct.
Sir, suppose we give x as 1, and then y as 2, and z as 3. We get 0 in the numerator, I think.
No, we cannot. We cannot get 0 in the numerator. How can we get 0?
Sir, y minus z will be 2 minus 3 minus 1.
1, 2, 3. 1 plus 3 is 4. 4 square is 16. 2 square is 4. 3 square is 9. Okay, here you are telling we'll get 0.
Yes,
Okay.
sir, in the
Yes.
numerator.
Yeah. Okay, so obviously, see, it's not that XYZ can have all the values, right? In the next chapter, we'll discuss when we talk about equations. It's not that there are certain equations which are conditional.
Okay, sir.
So for some values, it might not satisfy the required condition. So at that point, we cannot apply. So here 1, 2, 3 cannot be applied, but you can have different other values.
Okay, sir.
I think if you go with 3 to 1, you can still get the answer. X has 3, Y has 2, and Z has 1.
Okay.
Okay, so we have to use it the other way around. That's all.
Okay. Thank you, sir.
Okay, next one. ABC is equal to 2. Fine, we'll discuss. Okay, if ABC is equal to 2, what is the required question? 1 divided by 1 plus A plus 2B to the power of minus 1 plus 1 divided by 1 plus 1 by 2B plus C to the power of minus 1 plus 1 divided by 1 plus C plus A to the power of minus 1. Okay. Now, this 2B to the power of minus 1 is nothing but 2 by B. Correct? It's 2 by B. Now, ABC is equal to 2. If ABC is equal to 2, can I say AC is equal to 2 by B? AC is equal to 2 by B. So, this 2B to the power of minus 1 can alternatively be written as AC. Yes? Correct? So, instead of 2B to the power of minus 1, I'll write 1 plus A plus AC. I'll repeat. How did we get that? We know ABC is equal to 2. Correct? ABC equals to, given in the question. Since ABC is equal to 2, I can write AC as AC is equal to 2 divided by B, sending B the other side. Now, in this particular equation, we have 2B to the power of minus 1. 2B to the power of minus 1 is nothing but 2 divided by B. Right? 2 divided by B can alternatively be written as AC. So instead of 2 into B to the power of minus 1, I'll write AC. Similarly, 1 divided by 1 plus. Now, this is what? This is B by 2. Half of B is B by 2. B by 2, now we know AC is equal to 2 by B. If I write the inverse of it, B by 2 will be equal to
1 by AC.
1 by AC. Correct? B by 2 will be equal to 1 by AC. So 1 divided by 1 by AC plus C to the power of minus 1 can be written as 1 by C. Then 1 divided by 1 plus C plus 1 by A. Now further simplify this. 1 divided by 1 plus A plus AC plus 1 divided by, I'll take AC as LCM, AC plus 1 plus A plus 1 divided by, I'll take A as AC, LCM, A plus AC plus 1. Further simplifying this, 1 divided by 1 plus A plus AC plus AC will go to the top, AC divided by AC plus 1 plus A. Again, A will go to the top, A plus AC plus 1. Now, in all the three, the denominator is the same.
Yes, sir.
1 plus A plus AC. So 1 plus A plus AC. I have to just add the numerators. 1 plus A plus AC. We get 1. We get 1 as the answer. Right? So everything was there in the first step. So we have to write 2b to the power of minus 1 and 1 by 2b in terms of ABC is equal to 2 requirement. If we write that, if we get that, then it's just simple simplification of the problem. Okay, so the answer is 1. Then last one. Okay, if 3x minus 2 divided by 5x minus 6 is the duplicate ratio of 2 by 3, then the value of x. What is duplicate ratio?
Square of both.
Square of the same
Option
ratio.
A.
So that is compounding with the same ratio. So 3x minus 2 divided by 5x minus 6 is the duplicate ratio of 2 by 3.
Sir, 2.
No. None of the options are correct. Okay.
Answer is 3, sir.
Option B.
No.
By 7. 6 by 7.
Minus 6 by 7. 3x minus 2 divided by 5x minus 6 is the duplicate ratio of 2 by 3. So should be equal to 4 by 9.
Yes, sir.
Duplicate ratio of 2 by 3 is 4 by 9. Correct. So further simplifying this, 27x minus 18. 9 into 3x minus 2. 9 3s are 27. 9 2s are 18. Will be equal to 5x minus 6 into 4. 5x into 4 is 20x. 6 into 4 is 24. So 20x, I'll send it this side. It will be 27x minus 20x is equal to minus 24 plus 18. So 27x minus 20x is 7x. Minus 24 plus 18 is minus 6. X is minus 6 by 7. So if you want to get any of the answers here, you have to take this ratio as root 2 by root 3. Okay, the question, there is a printing mistake in the question. Root 2 by root 3. If we take root 2 by root 3 as a ratio, then its duplicate ratio is 2 by 3. Right? 3x minus 2, 5x minus 6 is equal to 2 by 3. Now further simplifying, 3x minus 2 into 2, 9x minus 4 is equal to 10x minus 12. So send this and this. 10x minus 9x is equal to 12 minus 4. X is equal to, no, we missed something.
6 instead of 4.
Okay, 6. 3 2s are 6. Okay, 3 2s are 6. So is equal to 6. So the answer is 6. So it should have been root 2 by root 3 instead of 2 by 3. Okay, so these are the 10 questions that were there from the first chapter. Okay, out of the 10, yes, 3 questions were standard, no doubt about it. Okay, out of the 3 also, the 1 or 2 questions, if we get the first part of it, then nothing is there subsequently. Yes, obviously, one of the question was completely standard, and that we have to expect one of the questions to be standard. And we need not bother about that particular question. We'll focus on the balance 8 or 9 questions that we have in hand. Right? So this is about equations. If you want, we can look into a couple of more questions. We'll solve this. Ratio of number of boys to number of girls in a school of 720 students is 3:5. If 18 new girls are admitted in the school, find how many new boys may be admitted so that the ratio of number of boys to the number of girls may change to 2:3.
42.
42.
42, sir.
Yes, 42 is the correct answer. How did we get 42? We'll discuss. See, there are 720 students, right? What is the ratio of girls to boys? Sorry, boys to girls? 3:5.
3:5.
So 3:5 means number of boys is 720 into
270.
3 by 8, which is
270.
270.
Girls,
450.
450.
girls is 450. Now they are saying 18 new girls are being admitted. So if 18 new girls are being admitted, 468 total girls, right? 468 total girls. Now they are saying what is the number of boys to be admitted so that the resultant boys is to girls ratio is 2:3. So if this has to be in the ratio of 2:3, I know 3 represents 468. What does 2 represent? It is just cross multiplication. 468 into 2 by 3. What is the value that we get? 468 into 2 by 3, 312, I think.
Yes, sir.
312. Now we already have 270 boys. We require 312 boys. What is the additional boys to be admitted? 42.
42.
That's all. 42 is the additional boys to be admitted. Next one. Yes. Find in what ratio will the total wages of the workers of a factory be increased or decreased if there is a reduction in the number of workers in the ratio of 15:11 and an increment in their wages in the ratio of 22:25. So what is the ratio of change in wage? That could be increase or decrease. We do not know. So they have given us number of workers ratio, old versus new, and they have also given us wages of each worker, old versus new. We have to find out total wages ratio, old versus new.
Is it 5/6?
Not 5/6, but I think you're near.
Six by 5.
Yes, it is 6/5. So 6/5 means increase or decrease?
Decrease.
Decrease, correct. Old was 6, new is 5. So it's a decrease in ratio. Perfect. Now, what have they given us? They have given us number of workers ratio of 15:11. So earlier, if the total number of workers were X, what is the new number of workers now? 11x by 15. Because old was in the ratio, if old was 15, new is 11. There is a decrease in the number of workers. So 11 by 15 into X is the new number of workers. Old, if the wages per employee, per worker was Y, what would be the new wages? What is the new wage? It is in 25. So 25Y by 22, right? 25Y by 22. Not getting this? Understanding?
Yes, sir.
Yes.
Yes.
Sir.
Okay. So if original number of workers were X, new number of workers would be 11 by 15 into X. Original salary per employee is Y, 25 by 22 into Y. So then in such case, what would be the total salary earlier? Number of workers per worker salary, X into Y. Now what would be the salary total? 11x divided by 15 into 25y divided by 22. Total number of workers into per worker salary will give me my total salary. So 11 ones are, 11 twos are, 5 threes are, 5 fives are. This will get us with 5 by 6 xy. X into y, 5, 3 twos are 6, 5 by 6 xy. Now what do we require? We require the ratio of original salary is to revised salary, total. Original salary is xy. Revised salary is 5 by 6 is to xy. So xy will remain 1 is to 5 by 6. 1 is to 5 by 6. If I can alternatively present it by multiplying throughout with 6. Both sides multiply by 6. So 6 is to 5. So 6 is to 5 is the ratio. If original total salary was 6, new total salary is 5. So there is a decrease in the salary. There is a decrease in the salary. Okay, that is how we have to solve this. Then one more question we'll solve in this chapter. This, yes, find the value of k from root 9 to the power of minus 7 into root 3 to the power of minus 5 is equal to 3k. Since
minus 19 by 2.
right, so since the right hand side equation is in the base of the equation is 3, left hand side also have to be presented in the form of 3 itself. So how do we present it? Root 9 is 3, correct? 3 to the power of minus 7 into root 3 to the power of minus 5 can be represented in the form of 3. What is root 3? 3 to the power of 1 by 2. Correct? 3 to the power of 1 by 2 into to the power of minus 5 will be equal to 3 to the power of k. So 3 to the power of minus 7 into 3 to the power of 1 by 2 into minus 5 is 3 to the power of minus 5 by 2 is equal to 3 to the power of k. So minus 7 minus 5 by 2 is equal to 3 to the power of k. Minus 7 minus 5 by 2 is equal to k. So 2 LCM minus 14 minus 5 is equal to k. Therefore, k is minus 14 minus 5 is minus 19 by 2. Minus 19 by 2. Okay. So these are some of the questions. So we can solve some more questions while during our preparation. Okay. So that we are thorough with this concept. With regard to ratios and proportions, some of the properties are important, and in indices also the properties are important. In indices there could be some tricky questions that can be asked. Okay, we have to be ready for it. 1 or 2 tricky questions can be asked. So this is the first chapter. Can I move on to the next chapter?
Yes, sir.
Yes, sir.
Yes, guys, are we following?
Yes, sir.
Yes, sir.
Yes,
sir.
Yes, the next chapter, time value of money. Again, an important chapter, but it's easy, it's common sense. Basically, time value of money is what? Paying interest, right, on the deposits, on the loan, on the money that have been taken. Now, why interest have to be paid? One is time value of money. The first reason, that is value of money today and the value of money in future, tomorrow or after 1 year, 2 years, 3 years would be different. The value of money is stronger today. Value of the money gets weakened as the day goes on. So that is one of the reasons why they will have to compensate. That compensation for the reduction in the value of the money is in the form of interest. That is one of the reasons. Second reason is opportunity cost. What is opportunity cost? Now I have deposited in a bank. They are giving me interest. Instead of that deposit, I could have invested somewhere else and I would have earned some returns there also. So the interest or the return that I'm losing by not investing there is called the opportunity cost. So because I have invested in this deposit, I could not invest there. Thereby, I'm losing that return. So that is the opportunity cost. So since I would have earned better, I would have earned some returns somewhere else. This party has to give me that return in the form of interest. Third one, inflation. So we all know what is inflation, right? Fall in the purchasing power of the money. So due to inflation, a given amount of money buys fewer goods in the future than it will now. Therefore, compensation for the same. Liquidity preference. Now, given preference, whether you wish to convert the cash today rather on a future date, it is immediate conversion would be given a preference. Right? So immediate conversion would be given a preference. So liquidity would be preferred. So if I have to deposit for 5 years, he has to give me some compensation. Then risk factor. There will always be a risk, right? I'm depositing, I'm giving loan to someone. There will always be a risk that he will default. So to cover that risk, he has to give me a return. That is called interest. So these are the reasons why interest would be given. Now, what is the interest? What is interest? Definition: interest is the price paid by the borrower for use of lender's money. The amount that they have taken, borrowed, is called the principal. The rate at which interest is given is called the rate of interest. Rate at which interest is charged for a defined length of time for use of principal, generally on a yearly basis, is known to be the rate of interest. Rate of interest is generally expressed in percentage. And accumulated amount or accumulated balance is principal plus interest, which is not yet paid, unpaid amount. Principal plus interest is called the accumulated amount. Okay, we have to be aware of these, because in certain cases they can ask us calculate the accumulated amount or accumulated balance in this case. So this is the principal given, this is the rate of interest for so many years, calculate the accumulated amount, they can ask us. So we have to be aware of the terminologies. In calculation of interest, we have two parts: simple interest, compound interest. What is simple interest? Simple interest is calculation of interest on the original principal only. The interest that we have already paid, that or which is yet to be paid, will not be added to the principal to calculate the interest. Interest will not be compounded. That is simple interest. Simple interest is interest computed on the principal for the entire period of the borrowing. So it is calculated on the outstanding principal balance and not on the interest previously earned. So 5,000 rupees is the loan given at 10% interest per annum. What would be the interest for the year? 500. So that is simple 500. This is year 1. What would be the interest for year 2?
500.
It would remain 500. It is not 5,500 into 10%. It would be 5,000 into 10% only. That is simple interest. Right? How do we calculate simple interest? Principal into interest rate into time period. Principal into interest rate into time period will give us the simple interest. Whereas, what is compound interest? So in compound interest, we would compound the interest back to the principal and calculate the subsequent interest on the revised balance that we have, on the accumulated balance that we have. So compound interest is the interest that accrues when earnings for each specified period of time added to the principal, thus increasing the principal base on which subsequent interest is computed. So if we have deposited 1 lakh FD, okay, 1 lakh FD, interest rate of 5%, and they are compounding it, let's say half yearly, compounding it half yearly, paying, adding the interest component to the principal every half year. Now, if it was a simple interest calculation, at the first half year, what is the interest that they'll pay? 1 lakh into 5% into 6 by 12. Half year. 2,500. Second half year, that is end of the first year. 2,500 only. Why? Because this is simple interest. They are calculating it on the principal balance only. Whereas if it is a compound interest calculation, then first half year, what is the interest?
2,500.
First half year, no change, 2,500. Whereas second half year, it is not on 1 lakh, but it is on
2,562.5.
yeah, 1 lakh plus the interest of the first half year, 2,500, 1 lakh 2,500 into 5% into 6 by 12. Right? 1 lakh 2,500 into 5% into 6 by 12. Obviously, it will be a little higher than 2,500. So this is compound interest. Understanding the concept? So the difference between simple interest and compound interest is that in simple interest, principal remains constant throughout, whereas in case of compound interest, principal goes on changing at the end of the specified period. For a given principal rate and time, compound interest is generally more than the simple interest, obviously, because interest is calculated on the compounded balance. Now, while calculating the compound interest, the important concept that we have to focus on is the conversion period. What is this conversion period? What is this conversion? Conversion is converting interest back to principal, converting the interest into principal, basically the process of compounding. So we said interest is paid every 6 months, every half year, but it need not be the case that interest is compounded at that 6 month only, right? Compounding can happen on a different date. So period at the end of which interest is compounded is conversion period. That is the period, the date on which that 1 lakh FD will become 1,02,500. That date is called conversion date. The time period that is there, the time period, the frequency of conversion is called conversion period. When the interest is calculated and added to the principal every 6 months, then we say conversion period is 6 months. In this case, number of conversion period per year, what would be the number of conversion period per year?
1,
2.
2.
Right? Every 6 months, if there is a conversion, in 1 year, there will be 2 conversions. If loan or deposit was for 5 years, then what would be the number of conversions?
10.
10 per year to total of 5 years. So 10 conversions total in that 10 year. So if the conversion period is 1 day, that is every day interest is adding to the principal, then we call it compounded daily. In such cases, 365 number of conversions would be there in the year. If conversion period is 1 month, we say compounded monthly, 12 conversion periods. If conversion period is 3 months, then compounded quarterly, every 3 months means 12 divided by 3, 4 times in a year. 6 months conversion period means compounded semi-annually, half yearly, 2 conversions per year. 12 months means compounded annually, only 1 conversion per year. So this conversion is also very important while calculating what? Compound interest. While calculating compound interest. Now, how do we calculate compound interest? We understood the concept, but how do we calculate the concept? Amount at the end of the period will be equal to principal at the beginning of the period into 1 plus I to the power of n. 1 plus I to the power of n. However, if I want interest, how to calculate interest?
Minus P.
A minus P.
Minus.
Right? Amount minus principal, we get interest, which is nothing but P into 1 plus, what is amount? Amount is P into 1 plus I to the power of n minus P, principal. So if I take P common, 1 plus I to the power of n minus 1 will give me the interest. So if you want principal, the total amount, P into 1 plus I to the power of n. If I want interest, P into 1 plus I to the power of n minus 1. That's all. If I have minus 1 and a bracket, that is interest. If I remove these brackets and remove minus 1, that is the total amount. However, what is I here? I is not the rate of interest. I is annualized rate of interest. Annual rate of interest divided by the number of conversion period per annum. That means if the rate of interest is 10% and there are 2 conversion periods, then I is 5%. Because for every 6 months, they are giving me 10% interest. That means that every 6 months, I'm getting 5% interest per annum. Right? And n is not the total number of years. N is total number of conversions. So if the principal is 10,000, rate of interest is 8%, number of years is 5, and it is compounded every half yearly. In such case, how do we apply the formula? 10,000 into
1 plus 8 by 100 whole power 10.
1 plus
4
it's not 8
per-
by 100. 4 by 100. 8 by
4
2.
by 100.
Correct? 4 by 100 to the power of 5 into 2.
To the part time.
10. Correct. So that is how we calculate compound interest. Understanding? So we have discussed simple interest and compound interest. Compound interest, number of conversions, very important. The formula that I discussed just now, if I want to repeat, I'll repeat. No problem. P into 1 plus I to the power of n. What is I? I is rate of interest per annum divided by number of conversions per year. Number of conversions per year. Similarly, n is not the total number of years, it is total number of conversions. So if in a year there are 4 conversions and total number of years are 5, 4 into 5, 20 is the number of conversions. So n will be 20. Is that clear?
Yes, sir.
Yes, sir. Yes, sir.
Now, similar to that, the compound interest calculation that we had, we have something called effective rate of interest. Now, Even though the interest rate says 5%, effectively, if it is compounded half yearly, the effective interest that we get would be higher than 5%. Right? I'll give you an example. 1 lakh, let's say the interest rate is 5%. Okay, compounded half yearly. In such case, at the end of 6 months, what is the interest that I get? 2,500. At the end of next 6 months, the end of 1 year, what is the interest that I'll get? 1 lakh, 2,500 is the revised principal, because 1 lakh plus 2,500 into 5% into 6 by 12, which will be, what is the interest amount?
0.5.
2563.
2.5.
Yeah, 2563. So total interest is 5,063 rupees. So if I had at 5%, if I had to get interest, it should have been 5,000, but I'm getting 5,063. So the effective rate of interest is 5,063 divided by 1 lakh into 100, which is 5.063%. So even though the actual interest rate is 5%, the effective interest rate is 5.06%. Why? Because there are multiple conversions during the year and we are calculating interest at compounding rate. So how do we calculate this effective interest rate? Effective interest rate would be E is equal to 1 plus I to the power of n minus 1. That is actual interest rate and number of conversion periods. So if I have 5% as the interest with 2 conversions, 1 plus 5 by 2 is 2.5, 0.025 to the power of what? 2 conversions during the year, 2 minus 1. So 1.025 square is 1.0506 minus 1, which is 5.06%. That is what we had got with the previous example as well. So this is how we calculate effective interest rate. How are we calculating effective interest rate? 1 plus I to the power of n minus 1. Now, in compound interest, how are we calculating interest? In compound interest, P into 1 plus I to the power of n minus 1. This is how we calculate interest. So ignore this P, just apply what is there in the bracket, you will get effective rate of interest. Okay, so compound interest minus P, you will get effective rate of interest. Okay, next discussion is annuity. So in annuity, we have many discussions that we have to have. Annuity, what is annuity? Annuity is a sequence of periodic payments. Same amount would be paid in the same time interval. So every month, if I'm depositing 5,000 rupees in an account, that is annuity. Or every month, if I'm receiving 5,000 rupees from an account, same date, then that is called annuity. Same amount, same date. Right? Annuity can be defined as a sequence of periodic payments or receipts regularly over a specified period of time. There is a special kind of annuity also called perpetuity. What is perpetuity?
There is no end.
Yeah, correct. So there is no maturity period at all, right? It will go on forever. So that is perpetuity. It is it's a special form of annuity. It is one where receipt or payment takes place forever. Since payment is forever, we cannot compute future value of perpetuity. In annuity, we can calculate future value. What is future value? The value of the annuity as on the future date. Let's say a maturity date or on a specific date. But for perpetuity, since there is no maturity at all, there is no point in calculating future value of a perpetuity, and future value of a perpetuity cannot be calculated. Only present value of perpetuity can be calculated. To be called an annuity, a series of payments must have following features. What are the features? Amount received or paid must be constant over the period of annuity, and time interval between 2 consecutive payments or receipts must be the same. Now, with regard to annuity, we have 2 types: annuity regular and annuity due or annuity immediate. Annuity regular means payment or receipt happens at the end of the year. Annuity end of the year means end of the period. It could be month also. Okay. Annuity due or annuity immediate means payment or receipt happens immediate. Now, so if we are planning an annuity of 10 years, if it is annuity regular, then the payment happens in December of every year, end of every year. But if it is annuity due or annuity immediate, payment happens January of every year. So what is the difference? Interest will differ. In case of annuity due, interest would be higher because 12 months extra deposit would be there. Right? So in annuity due, the interest would be higher compared to annuity regular. Formulas are simple. Okay, for remembering the formulas for calculating present value of or future value in case of annuity, it is simple. We'll discuss about it. The difference between regular and due, how to identify in the examination. Simple. If they say amount is deposited at the beginning of the year, it is annuity due. If they say amount deposited at the end of the year, it's annuity regular. If they doesn't say anything, we presume that it is at the end of the year. It is annuity regular. Okay, then future value. What is future value? Future value is the value of an investment at some time in future. Now, the value of the investment that I've made now is 10,000. If I want to calculate its value after 5 years, then that is future value. Right? It's the tomorrow's value of today's money compounded at the rate of interest. So using compounded rate of interest, we would calculate the future value. How do we calculate future value? Future value is equal to present value into 1 plus I to the power of n. That is compounded rate of interest. Simple. 1 plus I to the power of n, same. Now in compounding also we are using compound interest also we are using the same formula, right? A is equal to P into 1 plus I to the power of n. So instead of A, you call it as F, future value. P here is principal. We call here it to be present value into 1 plus I to the power of n. That's all. We get the future value. We get the future value. However, future value of a single cash flow is the same. However, if it is in annuity, if we are receiving it in installments, in such cases, what is the future value? Future value is A into 1 plus I to the power of n is what the normal future value is. But you have to reduce it by 1 whole divided by I. A into 1 plus I to the power of n minus 1 whole divided by I. This is future value of annuity regular. If you want future value of annuity due, you have to just multiply this with 1 by 1 plus n. If you want annuity due, multiply it with 1 plus I. I'll again summarize the future value discussion. Future value of investments depends on whether you are getting a single cash flow or you are receiving it in annuity. If it is in single cash flow, normal compound interest formula, A is equal to P into 1 plus I to the power of n. If it is in annuity, then divide it into whether it is annuity regular or annuity due. Okay, if it is annuity regular, same formula, P into 1 plus I, but you have to reduce 1, P into 1 plus I to the power of n minus 1 whole divided by I. If it is annuity due, same thing, P into 1 plus I to the power of n minus 1 whole divided by I, but further multiplied with 1 by I, because one more year interest in case of due when compared to regular. That's all. So if we remember this, formula, we know how to do annuity due. Right? So these formulas are important in case of future value calculation. So future value, we have to just, when they ask us future value, we have to see whether it's a single payment or
Regular.
Installment.
Annuity, installments. So if it's single payment, the normal compound interest formula. If it's annuity, whether it's annuity regular or annuity due. Next one, present value. Now, what is present value? Present value is today's value of tomorrow's money. Now, if I know that in future, after 5 years, I'm receiving 50,000. What is this 50,000's value today? That is called present value. Right? That is present value. Now, we know how to calculate future value. A into P to the power, A is equal to P into 1 plus I to the power of n. A is equal to. But here, if I want to know what is P, P is present value. P is equal to A divided by 1 plus I to the power of n. That's all. Same formula, rearrange it in the other manner. Yeah, I'll be back to the whiteboard just a second. So this is how we calculate present value if we will be receiving only one amount in future. But if we are receiving in annuity, how do we calculate present value? A into P to the power of n minus 1, n1, that is A into 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n. This is how we calculate present value in case of annuity regular. In case of annuity due, what do we do? In case of annuity due, annuity regular plus initial installment would be the present value. Annuity regular plus initial installment would be the present value. So this is for future value. Those who are still writing, write down. Then we will move on to present value. Okay, in case of present value, same discussion. Present value also we'll have two categories: single cash flow and annuity. If it is a single cash flow, what is my present value? Future value divided by 1 plus I to the power of n. If it is annuity, annuity regular, annuity due. What is annuity regular? How do we calculate annuity regular? A into 1 plus I to the power of n minus 1
divided by I into
1 plus I to the power of
n.
Correct? This is how we calculate in case of present value of annuity regular. Present value of annuity due, A into 1 plus I to the power of n minus 1 divided by I into 1 plus I to the power of n plus the first installment, the initial installment. Plus the initial installment that is being made, because that is made immediately, right? The present today's value, that is today's value. So no discounting required in case of today's value. So present value as it is, first installment, today's installment as it is would be added. Is that clear? Yes. So these are the formulas that we have to remember here. Okay, write this down if anyone is still writing. Done?
Yes, sir.
Okay. Fine. So that's all. So that is with regard to annuity. So in annuity, we have discussed present value, future value. Then we have some small concepts which we'll look into quickly. Not so important. Sinking fund. What is sinking fund? Sinking fund is a fund created for a purpose, for a particular purpose. Okay. Now, it is a fund created for a specified purpose by way of sequence of periodic payments over time. Now, in depreciation accounts, if you remember, we had discussed there is one method called sinking fund method. Okay, in the syllabus it's not there. I think sinking fund method. Okay, in sinking fund method, what would have happened is whatever amount of depreciation that we have, we deposit that amount in a fund. Okay, sinking fund, so that at the end of the useful life of the asset, we would get the value of the asset as it is to replace that asset. So same concept. So if I want some funds for a particular purpose, so every year I'll deposit an amount in that fund, so that at the end of the target year, I'll get that appropriate amount, the target amount that I had after considering the interest rate. So that is sinking fund. Interest is compounded at the end of every period. The size of the sinking fund deposit, what is the amount of deposit that we have to have, is computed using this formula. P into A, that is the future value after considering N and I. So basically the compound interest formula, the same compound interest formula should be applied. Apart from this, where do we apply this time value of money? We apply this time value of money in case of leasing. What is leasing? It's an arrangement wherein owner, the lessor, allows the user of the asset, that is the lessee, to use that asset for a definite period of time for a consideration. Now, how will this consideration be fixed? That consideration will be fixed by considering this time value of money. Then we have something called capital expenditure, investment decision. Okay, you will learn this more in intermediate in financial management. There we have something called NPV, net present value. Okay, so when we are going for an investment decision, whether we have to invest in that particular property or whether we have to invest in that particular machinery asset. So it's a capital expenditure, capital decision that we have to take. So at that point in time, we have to compare the outflow that we are having and the inflow that we get, the benefit that we get from that particular asset. So obviously the benefit would be there over the years, right? Now that I'll be receiving money, let's say in the next 10 years for that particular asset, from that particular asset. So obviously the value of that asset, the amount that I'm paying now, the amount that I'll receive in the 10th year cannot be compared. Why? Because of time value of money concept. So what we have to do, we have to convert all these 10 years receipts using the time value of money, convert it into present value, compare this present value that you are paying, and then appropriately decide. So for investment decision making also, we use this. Similarly, for valuation of bond, what is a bond? It's a kind of a deposit wherein they'll accept money in consideration for interest for a particular period of time. So how will the interest be valued? How will the interest be fixed with regard to that bond? Based on this concept of time value of money. So these are some of the applications of time value of money. Next one is extension of annuity, which is perpetuity. What is perpetuity? Perpetuity is an annuity where periodic payment or receipts begin on a fixed date, continue indefinitely, perpetually. Fixed interest payment on permanently invested sums of money are being paid are the prime examples of perpetuity. So 2 points are important in case of perpetuity. Value of perpetuity is finite because receipts that are anticipated far in future have extremely low present value. Today's value of future cash flow would be very low because perpetuity, it will go on and on, right? Additionally, principal is never paid. Since principal is never repaid, there is no present value for the principal. So whenever we are calculating the present value of annuity, we are only calculating the present value for the interest that we will receive, not on the principal, because there is no maturity period upon which we will receive back the principal. Principal is never repaid back, right? Therefore, perpetuity is simply the coupon amount over the appropriate discount rate or yield. So how do we calculate the present value of an perpetuity? It is interest or the amount returns that we get divided by the discount rate. So if I'm receiving 10,000 interest, discount rate is 5%, 10,000 divided by 5% is the present value of the annuity. That is how we have to calculate it. However, in certain cases, there could be something called growing perpetuity. What is growing perpetuity? First 5 years, I'll receive 10,000. Next 5 years, I'll receive 15,000. Subsequent years, 5,000 extra. So the amount that I'll receive will keep on increasing. We call it growing perpetuity. In that case, that growth rate also should be given effect to. Therefore, in such cases, return divided by I will not be the value of perpetuity minus that growth rate in the denominator. So let's say the growth rate is 5%. In such cases, if the discount rate is 10%, 10,000 divided by 10% minus 5% of growth rate will be my present value of annuity. So present value of perpetuity normally is interest or returns divided by the discount rate. But if there is a growth involved in the perpetuity, then it would be returns or interest divided by I minus growth, G. I minus growth rate. Okay. Then net present value, what I was discussing in investment decision making, not so important now, but it is very important in intermediate. Net present value is present value of cash inflow minus total initial investment that I'm doing now. So I'm purchasing a machinery which gives me a cash inflow of 1 lakh for 5 years. The purchase price of the machinery is 3 lakhs. So whether I can go ahead with the purchase of that machinery, by looking at it, yes, I'll receive 5 lakhs in 5 years, but I'm paying only 3 lakhs. There will be a profit of 2 lakhs. But no. But why? Because 3 lakhs I'm paying now, but I'll be receiving 5 lakhs in installments over 5 years. So the 1 lakh that I'll receive after 5 years would definitely be valued at 60,000 or 70,000 now. Correct? So we have to go with present value of cash inflow, not the exact cash inflows that we are estimating. Present value of cash inflow, calculate the present value. Let's say it comes to 3,25,000. Now compare this with the outflow that is happening. So since this is positive, there is a net positive result, go ahead with that decision. Okay, that is how NPV works. So if NPV is greater than 0, profit, so accept the proposal, else reject the proposal. Now in compound interest, we have discussed effective rate of interest. Similarly, we have something called nominal rate of return. Okay, what is nominal rate? Nominal rate is the rate that is given by the banker. That is stated interest rate. So if the banker says 5% interest, FD interest, so 5% is the nominal rate. Okay, 5% on annual savings account or FD, etc. However, what is real rate of return? Real rate is, as it says, it's the real effective rate that I get after considering inflation, compounding, etc. So nominal rate of return minus inflation is real rate of return. Nominal interest rate is equal to real interest rate plus inflation effective rate. Okay, so even though I'm getting 5% interest, that 1 lakh rupees would be 1,05,000 after 1 year. But because of inflation, let's say there was 4% inflation, the net increase that I got was only 1%. Because 5% interest that I received, 4% was inflation. So net interest, we call it real rate of return, was only 1%. Okay. Now, how do we calculate this? If interest is paid m times in a year, it can be found out by 1 plus I divided by m into m minus 1. Same compounding interest, effective rate of interest formula. Okay. Instead of their number of conversion, we call it n. Here they're calling it m. That's all. Last concept, we have something called CAGR, which is normally used in case of investments, shares, mutual fund investments, etc. They go with CAGR rate, compounded annual growth rate. Okay, it's a business and investing specific term for smooth the annualized gain of an investment over a given time period. It's not an accounting term, but it remains widely used specifically in investment related markets. How do we calculate this? Value of that investment at the maturity period divided by value of the investment now, that is value when the time period is n, value when the time period is now, beginning time period, to the power of 1 divided by tenure n minus t0 whole minus 1, we get CAGR rate. Again, this is just for our reference, not so important from examination point of view. Okay, so if just remember that formula in case if it is asked. Definitely 99% it will not be asked, but we can never say it might be asked also. So go through that formula. Okay, so this
is, can you give an example for CAGR computation?
Computation. Okay, computation we can refer. We'll look into some. We'll look into an example given in the material itself later.
Okay.
Okay. Right. Okay. So this is about time value of money, an extremely important chapter, 10 to 12 marks from this chapter. So what are there in this important concepts are simple interest, compound interest calculation, and then annuity calculation. In annuity, we have future value, present value. In each future value, present value, we have different categories that we have discussed. And then we have discussed about perpetuity. These are the important concepts in this chapter. Okay, if we go through this, we can easily attempt all the questions here, unlike the previous chapter where 1 or 2 questions could be tricky. But here, all questions would be easy. We can attempt. But we have to know the formulas. Formulas are very important. Unless we know it, we cannot. Okay, fine. So can we look into some questions?
Yes, sir.
In what time will be a sum of money double itself at 6.25% per annum simple interest?
$16.
Yes, 16 years. So it's simple. We'll go with the same formula. Then I will look into the shortcut also. So how do we calculate simple interest? Principal into interest rate. Here interest rate is 6.25% into time period, right? Time period we do not know, T. Now, if the amount have to be doubled, what should be the total interest that I have to get?
The principal.
Equal to principal, right? Total amount that I have to get should be, total interest that I have to get should be equal to principal. So principal gets knocked off. So I have 1 is equal to 6.25% of T, or T will be equal to 1 divided by 6.25%, which is 16 years. So alternatively, instead of going through these steps, whenever they ask us double simple interest, just go with 1 divided by rate of interest. You will get the number of years. Okay, you'll get the number of years, 16 years. Then Mr. X invests 10,000 every year starting from today for the next 10 years. Suppose interest rate is 8% per annum compounded annually. Compute future value of annuity, given that 1 plus 0.08 to the power of 10 is 2.158925.
Option B.
This is what I said. Read the question carefully. Future value, there are 2 types. Whether it is a single amount or an annuity, they have specified, I think, annuity. Yes, this is annuity. Under annuity, we have 2 types again, annuity regular or annuity due. Whether it is annuity regular or
Annuity due.
Yes. Why? Starting from today. Since it states starting from today, it is immediate, annuity immediate or annuity due. So we have to apply annuity due formula. So future value of annuity due formula, what is that? P into 1 plus I to the power of n P into 1 plus I to the power of n
Minus 1 divided by
divided by
R.
R or I. Yes, correct. And since it is due,
Into
further
one.
multiply with
1 plus
1
R.
plus I.
1 plus R. Correct. So we have 10,000 P. R is 8% compounded annually. So we can directly take it. 1.08 to the power of 10 minus 1 divided by 0.08 into 1.08. 1.08 to the power of 10, they have given this. So when they have given that, you have to use that only. Okay, you cannot use 4 decimals. Since they have given the 6 decimals, you have to use that 6 decimals only. So 10,000 into 2.158925 minus 1 divided by 0.08 into 1.08, we get
Option A.
option A.
Option A, 156, 454.88. So if we had missed this and if we had ticked B, if you do not multiply with 1.08, we still will get 1,44,865 if you go with annuity regular. So we think we have done correctly, but technically we have lost 0.25 marks there. Right? So we have to be very careful. This is the silly mistakes that we do in the exams. We'll know the concept, but we'll not apply it correctly. Next one, the difference between simple and compound interest on a certain sum of 3 years at 5% per annum is 228.75 rupees. Compound interest on the sum of for 2 years at 5% per annum is. So difference between simple interest and compound interest for 3 years at 5% is 228.75. Using that hint, calculate compound interest for the same sum 2 years at 5%.
$3,075.
Yes, 3,075, correct. What have they given us? They have given us simple interest and compound interest for 3 years at 5%. So calculate simple interest. X into 5% into 3 years. We get 0.15x. Correct? This is the interest, simple interest. Similarly, compound interest, what is the amount that we get? X into 1.05 to the power of 3. What is 1.05 to the power of 3? 0.1576. 0.1576. Yes, 0.1576x. Correct. This is the compound interest that we get. So what is the incremental interest that we are getting? 0.0076x. This is 228.75 rupees. They have given us difference of the interest. So what would be x value? 228.75 divided by 0.0076. We get 30,000. Yes or no?
Yes, sir. Yes.
Yes, we get 30,000. So if we have to take furthermore decimals so that we get the exact amount of 30,000. If we take 0.007625, I think the next two digits. If we take that, we get exactly 30,000. Now I know the principal amount. What I have to do? I know rate of interest. I know the period. I have to just calculate compound interest. 30,000 into 1.05 square. So this would be 33,075. This is the final total amount. So 33,075 minus 30,000 will give me the interest of 3075. So this is the interest. Yes. Next. How much time would simple interest on a certain sum be? 0.125 times the principal at 10% per annum.
Option A.
Yes. So what are they saying? They're saying that simple interest is 0.125 times the principal. So if principal is x, simple interest is 0.125x. Right? 0.125x will be equal to principal into 10% into time t. So 0.125x is equal to 0.1x into t. Therefore, t is 0.125x divided by 0.1x. X goes off. 0.125 divided by 0.1 is 1.25 years. So 1.25 is nothing but 1 by 4. Option A. Simple. Next question. The time by which a sum of money is 8 times of itself, if it doubles itself in 15 years, interest compounded annually. So it's not simple interest, compound interest. It's a little tricky. And the options also there, it's very near 42, 43, 45, 46.
$45.
Correct. 45. How did we get this? They are saying x becomes 8x in 15 years. Correct? No. X becomes 2x in 15 years. It doubles itself in 15 years. X becomes 2x in 15 years. So I'll apply compound interest formula. 2x is equal to x into 1 plus I do not know the rate of interest to the power of
15.
15. Correct? So x gets knocked off. 1 plus I to the power of 15 is equal to 2. Right? Now, if I have to apply the same concept with 8x also, but I do not know what is I, 1 plus I. Unless I know 1 plus I cannot do anything. So what I'll do, 1 plus I, I'll take 15th root on both sides. So if I take 15th root on both sides, this will be 1 plus I, because 1 plus I to the power of 15 into 1 by 15, this gets knocked off, it will be 1 plus I is equal to 2 to the power of 1 by 15, because I'm taking 15th root on both sides. So using this, I have to find out at what, by what time it will become 8 times. So 8x is equal to x into 1 plus I to the power of n. 8x, again, x gets knocked off. 8 is equal to 1 plus I is 2 to the power of 15. 2 to the power of, 1 by 15, 2 to the power of 1 by 15 to the power of n. So I know a to the power of n to the power of m is a to the power of m into n. Right? So 8 is equal to 2 to the power of 1 by 15 into n, which is 2 to the power of n by 15. 8 is equal to 2 to the power of n by 15. Can I express 8 in the form of 2 power something?
2 cube.
Yes. 2 cube is equal to 2 to the power of n by 15. Therefore, can I say n by 15 is equal to 3?
Yes, sir.
And n is equal to
45.
15 3s are 45. So n equals 45. Is that clear?
Sir,
Yeah. Yes.
so here 1 plus I whole power 15 equals 2. Can we take cubes?
Can we take cube?
Cubing on both sides.
Cubing on both sides, what happens?
1 plus I whole power 15 whole cube equals to 2 cube.
You can do that. You can do that. Yes. Easier method. I'll explain that as well. So what they have given, 2x is equal to 1 plus I to the power of 15, x into. So x gets knocked off. 2 is equal to 1 plus I to the power of 15. But what I require is 8x. So to get 8x, what I'll do, I'll cube on both sides. So if I cube on both sides, this is 2 cube. 2 cube is 8. That is 8 times the money. 8 times the money can be achieved in 15 to the power of 3. 15 to the power of 3 is 15 3s are 45. Right? 15 3s are 45. So 1 plus I to the power of 45. So which can be achieved in 45 years. Yes, that can also be done. Good. Next question. Present value of a scooter is 7290. If its value decreases every year by 10%, what then the value before 3 years is equal to? Very simple. For this we need not use pen, pencil, etc. In calculator itself we have to calculate just 3 steps. What are they saying? Value is decreasing 10% every year. Apply depreciation concept. So 7290 is after 3 years depreciation of 10%. Correct? So what we have to do? 7290 is 90% of last year divided by 90%. So now I am in the second year, divided by 90% of last year. Now I'm in the first year, divided by 90%. I'll get 10,000. I'll repeat. See, 7290. This is at the end of third year. Year 1, year 2, year 3. At the end of third year, I'm getting 7290. After what? After reducing 10%, 10%, 10%. So if I have to know what is the value at the beginning of the first year, I have to add back 10%, 10%, 10%. Correct? So 7290 represents 90% of last year because I've removed 10%. So 7290 divided by 90%, I'll get 8,100. Right? 8,100 into 10% is 810. If I remove that, I'll get 7290. Now this is again 90% of last year. So again, I have to do 90%, which I'll get 9,000. This is at the end of first year. First year I have done 10% reduction. So which is again 90%, which is 10,000. So originally the value of the scooter was 10,000. First year 10%, 1,000 reduction. Second year 10%, third year 10%. Therefore at the end of year 3, I'll get 7290. So present, the value before 3 years is 10,000. Getting this? Next one. Find the effective rate of interest at 10% per annum when the interest rate is payable quarterly. Okay, solve it. Now solve it. Okay, solve it. Later I'll
10.38%.
Yeah, it has to be 10.38 in this options. In examination, the options need not be the same. Since the rate of interest is 10%, obviously the effective rate should be more than 10%. So logically, we have to go with 10.38. But in exams, we do not know. We can get 10.1, 10.2, 10.3, 10.4. In such cases, we have to solve. How to solve it? 1 plus 0.1 divided by quarter. So every year, what is the
4.
conversion period? 4. Number of conversions are 4. Divided by 4 to the power of 4 minus 1. Correct? So 1 plus 0.1 divided by 4 is 0.025 to the power of 4 minus 1. 1 plus 0.025 to the power of 4 is 1.1038. Minus 1, we get 0.1038, which is nothing but 10.38%. 10.38%. Next, the difference between simple interest on a sum invested of 5,500 for 3 years is 18 rupees. The difference in their rate. So they have calculated simple interest with 2 rate of interests by considering 2 rate of interest. By considering those 2 rate of interest, the simple interest that they got, the difference among those 2 simple interests is 18 rupees. So find out what is the difference between those rates.
.4%.
0.4. How did we get 0.4? See, 18 is the difference in the simple interest. So if I 1,500 if I multiply 1,500 into 3 years into that rate of interest, I should get 18, the differential rate of interest. Correct? I'll consider this as x. So 4,500 into x is 18. X is 18 divided by 4,500. We get
0.4.
0.4.
Yeah, 0.004. Since we are representing it in percentage into 100, we get 0.4. So 0.4 is the difference between those rate of simple interests. What will be the population after 3 years when the population increases at the rate of 3% in 1 year, 4% in 2 years, and 5% in 3 years? They have not given the population today. Printing mistake. Population today is 25,000. Simple application of calculator. We'll get the answer.
28,119.
That's all. 25,000 plus 3% plus 4% plus 5%. We get 28,119. Next, if 10,000 is invested at 8% per annum, compounded quarterly, the value of the investment after 2 years.
10,824.3.
Option is not there.
$11,716.59.
So what are we supposed to do? This is compounding quarterly. So 10,000 into 1 plus 0.08 divided by
4. Divided by
4 into 2 years into 4 per year. 4. So 10,000 into 1.02 to the power of 8 will give us 11,716. Yes. Next, in how many years will a sum of money become double at 5% compound interest?
14.3.
solve. So what are they asking? They're asking how many years it will double. So 2x is equal to x into 1.05 to the power of n. X gets knocked off. 2 is equal to 1.05 to the power of n. So from here we have to move on. How to further
Option D.
simplify? Yeah, obviously option D, correct. Going with the options, this should be the correct option, no doubt about it. But if they say 14.5, 14.7, 14.8 in such cases, so we cannot further move unless we apply trial and error method or apply logarithms. Correct. So for application of logarithms, they have to give us log tables. So in examination, don't worry, they will give you log tables. Okay. So by applying logarithms, how do I apply logarithms on both sides? Log 2 is equal to n log 1.05. I want n. So n is equal to log 2 divided by log 1.05. Log 2 is 0.3010 and log 1.05 is again 0.0212. Okay, it will be given in the exams, nothing to worry. So further simplifying, n will be 14.2 something, 26 or 27 something it will come. So round it off to 14.3 years. So this is the answer. Trial and error becomes difficult because 14.3, if it's a round figure, 14 years, 15 years, 1.05 to the power of 2, 3, 4, 5, we'll get 2. But since it is 14.3, still we can do it. To the power of 14, to the power of 14 would be less than 2, to the power of 15 would be more than 2. So in such cases, obviously it should be 14.3. But it will not be possible when the options are 14.3, 14.5, 14.6, and 14.7. In such cases, we have to go with log tables. Okay, such type of questions, they'll give you log values. Next, the last question. Future value of an annuity of 1,000 rupees is made annually for 5 years at interest rate of 14% compounded annually. What is the future value? Read the question carefully, whether it is annuity, regular, or due.
$6,610.
6,610 or 160?
610.
Okay, so it is annuity regular or annuity due?
Regular.
Regular. Nothing specified, so it should be regular. Into 1.14 to the power of 5 minus 1 divided by 0.14. That's all. So simplifying this, they have given us 1.92541. So 1000 into 1.92541 minus 1 divided by 0.14, which is 1000 into 0.92541 divided by 0.14, which is, what is 0.92541 by 0.14?
61007.
Yeah, 6.6100. Therefore, it is 6610. It is 6610. Clear? Yes. So these are the questions that have been asked. So we have reached 26. We started with question number 1. In between 5 questions we have not discussed, that's all. So 21 questions we have discussed first 2 chapters out of 40, right? So these are the 2 chapters that are very important, and that is the reason we have spent so much of time. The other chapters obviously will not spend so much of time. Whatever is required we'll discuss in the other chapters after a break. Okay, before that, anyone has any doubts? That CAGR example we'll discuss after the break. We'll look into it. But apart from that, anyone has any other doubts?
No, sir.
Sir.
Okay, fine. So we'll take a break.
Yes,
Yes,
sir.
sir.
Yes, we'll come back at 8:32. 10 minutes.
Okay, sir. Thank you.
Okay, sir.
Thank you.
Okay, sir.
Okay, friends, are we back?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Okay. So in the first half, we discussed 2 chapters, right? Okay, we'll finish that Cagr computation. Then we'll come back. Yes. So this is one of the examples. So they have given us the revenues of 4 years, 13, 14, 15, and 16. They are asking us to calculate Cagr. So how are we calculating the Cagr? Value at the end of the period, value at the beginning, first year, last year, and first year. So 210 divided by 100 to the power of 1 divided by last year minus first year. That is 2016 minus 2013, 3 years. 2016 minus 2013, 3. So 210 by 100 into 1 by 3 minus 1. That is the percentage of Cagr. That is how Cagr would be computed. Okay. So
Okay, sir, got it.
yeah, fine. So we are done with 2 chapters. So this was for 20 marks. Now the balance 20 marks will come from 4 chapters. We have 4 more chapters, right? 4 or 6 more chapters. So we have equations, inequalities, then APGP, HP. Sorry, no, not HP, only APGP. Then we have one more. Permutations and combinations, and then sets and functions, and then calculus. So out of which the next 4 chapters that we are discussing, equations, inequalities, permutation, combination, and APGP, that will come for 15 marks. The last 2, sets and functions and calculus, will come for 5 to 6 marks in total. So we'll look into that at a later point in time, because there are some technicalities that are there. Some of us might get confused. So some of us might get confused. So even if we understand it, is difficult to apply. So what we can do, we can keep it at the end. Whatever is possible, we'll discuss in those chapters. These 4 chapters we'll concentrate so that we'll get 15 marks. We can score in these topics as well. So we'll start with equations. Equation. What is equation? It's a statement of equality, mathematical statement of equality, right? If the equality is true for certain values of variable involved, then the equation is called conditional variable equation. Why? Because if it is true only for certain values. However, if it is true for all the values, then we call it an identity. So this is an equation, x plus 2 by 3 plus x plus 3 by 2 is equal to 3. Why? Because it's whole good for only certain values of x. But x plus 2 by 3 plus x plus 3 by 2 is equal to 5x plus 13 by 6. This is an identity. Why? Because in all the 3 terms we have x. Therefore, it will hold good for all values of x. Hence, we call it identity. Now, identifying the values of the variable of that equation, we call it solution of the equation or root of the equation. An equation with the highest power of the variable as 1 is called linear equation. If we have 2, highest degree of 2, we call it quadratic. Highest degree of 3, we call it cubic equation, right? And if we have highest power of the variable as 1, but multiple variables, 2 or more variables, we call it simultaneous linear equations. If that equation has only one unknown x, that is simple equation. If it has multiple unknowns, x and y, etc., we call it simultaneous linear equations. So to solve a simple equation, only one equation is sufficient. But to solve a simultaneous equations, we want minimum 2 equations to get the solution. Now, in case of simultaneous linear equations, there are various methods of solving, right? Getting the solution. First one is elimination method. So what are we doing here? We are eliminating one of the variable. So let's say 2x plus 5 is equal 5y equals 9. 3x minus y is equal to 5. So how do I eliminate it? Multiply this with 5. So we get 2x plus 5y equals 9. 3 5s are 15x minus 5y is equal to 25. So plus 5y minus 5y gets knocked off. 17x is equal to 34. So x is equal to 2. If x is equal to 2, what is the value of y? Same, apply this in any of the equation. So 6x minus y is 5. 6 minus y is 5. So y will be equal to 6 minus 5, which is 1. So this is elimination method. We are eliminating one of the variable to find out the other variable. The second one is cross multiplication method. Okay. So in this method, x and y are calculated using this formula. That is, in any of the equation, we would denote the variables with certain values. 2x plus 5y is equal to 9. So here 2 is a1, 5 is b1, minus 9. 9 will be this side. 9 would be minus 9 would be c1. Similarly, the second equation, the coefficient of x would be a2, coefficient of y would be b2, the constant would be the c2 value. So how do we calculate x value? X value would be calculated using b1. So I will not consider this. I'll consider this b1 into c2 minus b2 into c1. b1 into c2 minus b2 into c1 divided by, now don't consider the last one, a1 into b2 divided by minus a2 into b1. So that is how we calculate x. Similarly, how do we calculate y? Ignore this, c1 into a2 minus c2 into a1 divided by, now ignore last one, a1 into b2 minus a2 into b1. That is how we calculate in case of cross multiplication. However, we need not bother about that. If it's a little confusing. We know how to solve simultaneous equations using the normal elimination method, right? We'll go with that method itself. Quadratic equation means highest power is, what is the highest power in case of quadratic equation?
2.
2. Highest power is 2, right? And in case of a quadratic equation where b is equal to 0, we call it a pure quadratic equation, and else it is affected quadratic equation. Now, in case of a quadratic equation, since it's power, the highest power is 2, it will have 2 roots. How do we calculate quadratic equation? We can solve it normally also, or using this formula, minus b plus or minus root of b square minus 4ac by 2a, or using that factoring method, identifying the two variables and splitting the equation. That can also be done. Okay. Using this formula, it is simpler, minus b plus or minus root of b square minus 4ac by 2a. Here, this b square minus 4ac is called the discriminant. Why we call it so? Is because it discriminates the roots. If b square minus 4ac is 0, then we call the roots as real and equal. If b square minus 4ac is greater than 0, then the roots are real and unequal. If b square minus 4ac less than 0, roots are imaginary. Right? If b square minus 4ac is a perfect square, then the roots are real, rational, and unequal distinct. If b square minus 4ac is greater than 0, but not a perfect square, then they are real, irrational, and unequal. Okay. Since b square minus 4ac discriminates the roots, we call it the discriminant in the equation. We call it the discriminant in the equation. If one root is reciprocal to the other root, so if a is one of the root 1 by 2, b is 2, one root is reciprocal to the other root, then we say in that equation c is equal to a. So in any quadratic equation, ax square plus bx plus c is equal to 0. So a is equal to c if one root is reciprocal to the other. Similarly, if one root is equal to the other, if a is equal to b, if a and b are the two roots, if a is equal to b, in such cases, this b by a will be equal to 0. Therefore, value of b is equal to 0. So when can we say that the roots, both the roots would be equal? When the quadratic equation is a pure quadratic equation. That is, b is equal to 0. If b equals 0, then the roots are equal. Okay, these are the points that we have to keep in mind. The equation is simple. We have to just solve and get the values, right? So we'll look into the question. Again, we have to go back. Yes, question number 11. If alpha and beta are the roots of the equation, 7x square plus 7x plus 12 equals 0, then the equation whose roots alpha plus beta square and alpha minus beta square will be. This is simple. What are we supposed to do? First, find out the roots of this. Then find out what are these two. Using these two values, construct an equation.
Option C.
Yes, correct. So first we have to find out the roots. What are the roots that we get? X square plus 7x plus 12?
3 and 4.
3 and 4. So minus 7 minus b plus or minus root of b square 49 minus 4 into 1 into 12 4ac divided by 2 into 1. Minus 7 plus or minus root of 49 minus 48 is 1. Root of 1 is 1 again. So minus 7 plus or minus 1 by 2. So one of the roots alpha would be minus 7 plus 1 which is minus 6 by 2 which is minus 3. Beta would be minus 7 minus 1 minus 1 which is minus 8 by 2 minus 4. So these are the values of alpha and beta, minus 3 and minus 4, not 3 and 4. So alpha plus beta whole square would be 3 minus 4 whole square is 49. 7 square. Alpha minus beta, alpha is minus 3. Minus of minus 1, minus 4 which is plus 1. Square is 1. So the two roots a plus b, alpha plus beta square, alpha minus beta square are 49 and 1. So using 49 and 1, what is the equation that we can construct? It is this equation, x square minus 50x. So 50x is 49 minus 49 minus 1. So option C. Option C is the answer. Next question, the question is wrong. Okay, we cannot get the answer. We have to change the question a little bit. Instead, we'll solve some other question. Okay, we'll go to the study material itself and solve some other question. First one, this one. Divide 25 into 2 parts so that the sum of their reciprocals is 1 by 6.
Six x square minus 6 plus 1.
Sorry, come again. 6.
6x square minus 6 plus 1.
No. What are we supposed to calculate?
10 and 15.
Correct. We are supposed to calculate the two values using which we can divide 25. 25 should be divided into 2 parts. Okay, 2 parts. So 25 should be divided into 2 numbers. So that those 2 numbers, if I add their reciprocals, I get 1 by 6 as the answer. So what I can do, I can consider one of the values as x, the other value will be 25 minus x. Since I am dividing 25 into 2 parts. So their reciprocals 1 by x plus 1 by 25 minus x will be equal to 1 by 6, sum of their reciprocals. So I'll take x and 25 minus x as LCM, then it will be 25 minus x plus x is equal to 1 by 6, minus x plus x gone. X into 25 minus x will be equal to 25 into 6, which is 150. So further simplifying this, 25x minus x square equals 150, or x square minus 25x plus 150 equals 0. Solving this,
10 and 15.
10 and 15. 25 plus or minus 25 square is 625 minus 4ac is 600. 4 into 1 into 150 is 600 divided by 2. 625 minus 600 is 25. 25 root is 5. So plus 25 plus or minus 5 by 2. 25 plus 5 by 2 is 15. 25 minus 5 by 2 is 10. So the two values which divide 25 with the sum of the reciprocals as 1/6 is 10 and 15. Okay, next. 13, right, this one. A number consists of 3 digits, of which middle one is 0 and the sum of the other digits is 9. The number formed by interchanging the first and third digits is more than the original number by 297. Find the number.
Six not 3.
No.
Three not
306. See, middle number is 0. We have to find out the other 2 digits. So we can say hundredths digit we can denote it by x, so that it will be 100 into x, 100x, and the single units digit to be denoted as y. Correct? Now they have given us x plus y is equal to 9. Sum of the digits are 9. And they're saying by interchanging this, that is 100y plus x, if I interchange the digits, it would be more than the original number by how much? 297. So 100x plus y is equal to 100y plus x plus 297.
97.
So further simplifying this, 100x minus x would be 99x, minus y plus y minus 100y would be 99y, will be equal to 297. So I'll bring 297 also this side, or rather not required. I'll take 99 as common. X minus y is equal to 297. So what would be x minus y? What is x minus y? 3. Correct? X minus y is 3. Correct? X minus y is 3. So x plus y is 9. X minus y is 3. 2x is 12. X is
6.
no. We did something wrong here.
So minus 297.
Minus 2x. Huh? How did we get minus 2x?
No, sir. I thought it was minus 297 there.
Okay. Minus 297. It's more. Okay. Okay. Correct. It is more by, right? So it should be minus 297, not plus. What this number is more than the original number by 297 means it should be minus 297. Correct. So it's minus 297. Therefore, x minus y is minus 3. Since x minus y is minus 3, x minus y is minus 3, we get 2x is 6. If 2x is 6, x is 3. If x is 3, y is 6. Therefore, the number is 306. Do I need to explain it again? Others understood?
Yes.
Yes.
Okay, okay, fine. Fine. So this is about equations. So they'll ask us solving the equations on certain cases like this, finding out the values of x and y, etc. Okay. The next chapter in that is inequalities, linear inequalities. Now, if we have equals in a particular statement, we call it an equation. But if in the statement there are two quantities which are not equal, in that case, obviously we cannot equate it, but there is a relationship between those two. So we will still bring it in a form of a statement using these inequalities. So 5 is greater than 3. It's one of the inequality, right? 5 is greater than 3. So we cannot say 5 is equal to 3. So that is linear inequality. In case of linear inequalities, we have something called solution space. What is solution space? Unlike equation, we will not have one solution here in inequalities, right? So we'll have an area of solution. We call that area of solutions as solution space. Now, if we say x is equal to 0, then we have only one solution, x equals 0. But if we say x greater than 0, then the value x can take any value greater than 0. So any value from here would be the solution. Therefore, we call it solution space. Similarly, x less than 0, any value from here, we call it solution space. Okay. Similarly, we can have it in the form of an inequation, that is 3x plus y is less than 6. So how do we denote it in the form of an inequality? What do? We use graphical representation. So 3x plus y less than 6. First, we would consider it an equation. Then I'll make x as 0. If x is equal to 0, y is equal to 6. If y is equal to 0, x is equal to 2. So then I'll plot that in a graph. 0, I want 6, right? So 2, 4, and 6. 2, 4, and 6. X is 0, y is 6. X is 0, sorry, y is 0, x is 2. So this statement, this line represents 3x plus y equal to 6. But I want 3x plus y less than 6. So this area represents the solution space. Correct? This area represents the solution space. Similarly, if we have two inequalities and if I want to find out the appropriate solution, in such case, what I'll do? The same exercise I'll do for both the inequalities. I'll bring the other inequality also and find out the feasible area for both. Let's say this is the feasible area. In such case, this is the solution space. So here I can find out the 4 optimum solutions. What are the 4 solutions? The 4 extreme points. The 4 extreme points are the 4 optimum solutions. So here I can find out this, I can find out this, I can find out this, wherever it is meeting the x-axis and y-axis. But this point, how to find out?
Solving the two equations.
Solving the 2 equations. The intersection of those will be found out using by solving those 2 equations, right? So that is how we'll find out the optimum values among them. So this is how we plot them in the graph. So how do we plot them in the graph? First, we have to formulate LPP, linear programming problem. Generally, it will be given in the form of inequalities. If it is not given, if it is in the form of conditions, we have to convert the conditions into inequalities. How to do that? We'll discuss one of the problems, no problem. Then plotting the capacity constraints on the graph. Capacity constraints are the inequalities that we have. Plot that in the graph. For this purpose, normally 2 terminal points are required. This is done by presuming simultaneously that one of the constraint is 0. So if x plus y is less than 5, we'll consider x as 0, so that we'll get y. Then we'll consider y as 0, consider x. When constraints concerns only one factor, then line will have only one origin point and it will run parallel to other axis. Once you have the inequality plotted on the graph, identify the feasible region. When identifying the feasible region, less than or greater than, we have to be careful with regard to the inequality. Lesser than or greater than, and coordinates of the corner points. Mostly it is done by breading the graph, but a point can be identified by solving simultaneous equation relating to 2 lines which intersect to form a point on the graph. Testing the corner point which gives maximum profit. So the 4 corner points we'll take. Those 4 corner points will test with the given requirement, which gives the maximum profit. That is the optimum solution. That is the optimum solution. That is the decision making that we have to come into. Okay, this is about inequalities. So what are we focused on here? We are focused on finding out the feasible values. And then LPP problems, we'll look into it in case if it is asked. Okay, generally it might not be asked LPP in the exams. However, in case if it is asked, we'll look into one question with regard to that. This linear inequalities is very simple, but not many questions will be asked in the exam. Maximum 2 or 3 questions in the exam, but we can answer both. On solving the inequalities, we get the following solutions. What are the solutions that we get? How do we get these solutions? We have 5x plus y less than or equal to
corner points of the feasible regions.
Correct. So first we'll plot them. 5x plus y is equal to 100. So how do I get the points here? X equals to 0, y will be equal to 100. If y equals 0, x will be equal to
20.
20, correct. So 20, 40, 60, 80 and 100. 20, 40, 60, 80 and 100. So if x is 0, y is 100. If y is 0, x is 20. So draw. This is 5x plus y less than or equal to 100. So this is my feasible part of this equation, because x and y should be greater than or equal to 0. It cannot be negative. Then other equation is x plus y is 60. So if x is 0, what is y? 60.
60.
Y is 0, x is
60.
60. So 0, 60, 60, 0. I'll draw a straight line. So this is the feasible point. So both, if I consider what is my feasible point, feasible portion rather, feasible area is this, correct? So what are the corner points? 1, 2, 3 and 4. 0, 0 is one of the corner points. Then this is 0, 60. This is 20, 0. The other one we can identify by solving the equations. 5x plus y is 100 and x plus y is 60. So minus minus minus, 4x is equal to 40, x is 10. If x is 10, what is y? X plus y is 60. If x is 10, y is 50.
50.
So 10 and 50 are the one of the this is one of the corner points. So do we have the options 0, 0, 20, 0, 0, 60 and 10, 50? So this is the corner points that we get. Clear? Next one. The rules and regulations demand that the employer should employ not more than 5 experienced hands to 1 fresh one. And this fact is represented by taking experienced person as X and fresh person as Y. So how do we denote this in the form of inequality?
Option B.
Option B. What are they saying? Y is fresh, X is experienced. They're saying I can have maximum 5 experienced for every 1 fresh. So if we go with this, 5 fresh less than or equal to 1 experience. No, it cannot happen that. So it should be y greater than or equal to x plus y. Y is fresh. So fresh numbers should always be greater than or equal to experience divided by 5. Or it could be 5x less than or equal to y. 5x less than or equal to y. That is also possible. That's all. So this is inequalities. We'll look into that LPP problem. Okay. A manufacturer produces 2 products A and B and has his machines in operation for 24 hours a day. Production of A requires 2 hours of processing in machine 1 and 6 hours in machine 2. Production of B requires 6 hours of processing in machine 1 and 2 hours in machine 2. Manufacturer earns a profit of ₹5 on each unit of A and 2 on each unit of B. How many units of each product should be produced in a day in order to achieve maximum profit? So what is the profits that he get? For product A, he gets 5x. Product B, he gets 2 rupees. So can I say 5x1 plus 2x2 are the profits that he'll get? Correct? Now, what are the inequalities that we can have here? What is the total number of hours? 24 hours. Machine A, machine M1, product A requires 2 hours. Product B requires 6 hours. Totally in a day, we have only 24 hours. So can I say 2x1 plus 6x2 for product A, I want 2 hours. For product B, I want 6 hours of machine A should be less than or equal to 24 hours. Similarly, machine 2, 6 hours of product 1, 2 hours of product 2 should be equal to 24 hours. And obviously, x1 and x2 should be greater than or equal to 0, the number of products that we produce. So solving this, we can easily solve this. We have 2 linear inequalities. Can we solve this? Yes. We plot, get the feasible area, get the 4 corner points. Once you have those 4 corner points, now by solving this, we'll get these 4 corner points, 0, 0, 0, 4, 3, 3, and 4, 0 are the 4 corner points. Now apply this in this profit equation, 5x1 plus 2x2, which gives the maximum, that is the optimum answer. So by applying that, 21 is the maximum. So 3, 3, produce 3 of product A, produce 3 of product B. That is the optimum. Okay, so that is extension of linear inequalities in case if it is asked. Linear inequalities, solving the inequalities, we all understood, right?
Yes, sir.
Yes, so solving the inequalities, we have understood. Subsequent application, if it is asked in the exams, that is the reason I've just discussed it. Generally, it will not be asked. Okay, so with that, can I move on to the next chapter?
Yes, sir.
Yes.
The next chapter is permutations and combinations. So we have something called multiplication and addition rule. Multiplication rule says if certain thing can be done in m different ways, and if it is done in m different ways, a second thing can be done in n different ways, then these two can be done in m into n different ways. So if we can go to school in 5 different buses and come back in 4 different buses, then we can have 5 into 4, 20 different combinations. 20 different combinations. Similarly, if there are 2 alternatives, let's say I can do a particular job in m different ways or can do a job in n different ways, then how many number of ways I will have? It's not m into n, m plus n. Why? Because it is or. I'll give an example. If we can go to school, if we are going to school by bus, we have 5 different options. If you are going to school by autos, we have 4 different options. So in that case, I have 9 options. I do not have 20 options here. I have only 9 options. So 5 plus 4, 9. So whenever it is and, we multiply. Whenever it is or, we add. Right? We have something called factorial. What is factorial? N factorial is product of all the integers from 1 to n. 5 factorial is 5 into 4 into 3 into 2 into 1. Correct? What is permutation? Permutation is the ways of arranging or selecting smaller or equal number of persons or objects from a group of persons or collection of objects with due regard being paid to order of arrangement. So the difference between permutation and combination is that in permutation, importance should be given to the order of arrangement of those objects. So NPR, we call n number of objects we have. In that, we have to select R number of objects. How do we do this? N factorial divided by NPR is equal to
N minus R factorial.
yes, n factorial
N
divided by
minus R the whole.
n minus R factorial. NPR is n factorial by n minus R factorial. Okay, that is what is given. What is NP1?
N.
NP1 is n. NP0?
1.
1.
NPN?
1.
1.
1.
NPN is 1. Then that is whatever we have discussed is linear permutation. We have something called circular permutation also. That is arrangement in circular order. So in that case, the number of permutations possible is n minus 1 factorial. The number of permutations possible is n minus 1 factorial. That is, if we have 5 number of people, if I want to arrange them in circle, it can happen in how many ways? 5 minus 1 factorial ways, 4 factorial ways. It can happen in 4 factorial ways. So normal permutation, it is n factorial by n minus r factorial. But in case of circular permutation, it is n minus 1 factorial. So in how many ways can 4 people sit around a table? 4 minus 1, 3 factorial, 6 ways. Thus, the number of ways of arranging up n people, n person along a round table so that no person have same 2 neighbors. No person have same 2 neighbors is n minus 1 factorial divided by 2. N minus 1 factorial divided by 2. This is when none of them will have same 2 neighbors. Similarly, a number of necklaces formed with n beads of different colors, etc. Such cases also we will have the same n minus 1 factorial divided by 2. Okay, these are all important. Direct questions would be asked. We have to just apply these concepts and get the answer. So these are important. We have to look into it. Apart from that, permutations with some restrictions. Number of permutation of n distinct objects taken are at a time, when a particular object is not taken at all. So we have 10 objects. I have to take 6 objects out of the 10, but I will not take one of the objects. In that case, what is the objects remaining? 9.
9.
So it should be 9p6.
9p6.
So how do we get that? n minus 1 pr. Similarly, I have 10 objects, but one of the object would compulsorily be a part of that 6 objects. It means that from the balance 9, I have to take 5. So that would be 9p5, which is n minus 1p r minus 1. n minus 1p r minus 1. Okay, then that is about permutations. Then we have combinations. Combination, the difference is without giving importance to order of selection or arrangement. What is NCR? NCR is n factorial by n minus r factorial into r factorial. So NPR is n factorial by n minus r factorial. Here, additionally, r factorial should be multiplied in the denominator. NC0 is
1.
NCN is
1.
1. Okay. Then some specific points. Permutation when some of the things are alike, taken all at a time. So when there are 3 different components, n1, n2, and n3, and if everything are taken at a time, then the corresponding permutation would be n factorial divided by not n minus r factorial, n factorial into n1 factorial into n2 factorial into n3 factorial. Okay. Then if permutations when each thing may be repeated once, twice, etc. If we can take the same thing again and again, then the permutation would be n to the power of r. So if we have 3 objects, it can be repeated any number of times. In such case, what is the permutation? 3 to the power of n number of times. If it can be repeated 3 times, 3 to the power of 3 is the permutation, 27 times. Then combination of n different things, taking some or all of n things at a time. So we have n objects. If we can take some or all of the objects at a time, in such cases, what is the combination? Combination, not permutation. 2 to the power of n minus 1. 2 to the power of n minus 1. We have to remember these things. Okay, we have no option. Then combination of n things taken some or all at a time, when n1 of the things are alike of one kind, n2 of things are alike of another kind, n3 of things are alike of third kind. So combination of second one and third one. Here, how do we get this? n1 plus 1 into n2 plus 1 into n3 plus 1, so on, minus 1. That is how we get that particular value. Now, let's say we have 2 sets, n1 objects which from which I require r1 things, n2 objects I require r2 things. These are independent. In such cases, what is the combination? I have to calculate the combination independently. n1 cr1 into n2 cr2 would be the combination required. This because they are independent of each other. They are independent of each other. That's all. So this is about permutation and combination. The properties, some of the properties that we have discussed here, focus on these properties. Apart from that, it would be simple application like this. We look into some questions. The number of ways of arranging 6 boys and 4 girls in a row so that all 4 girls are together.
Seven factorial.
7 factorial into 4 factorial. So 4 girls should be together. That can happen in 4 factorial ways. Now, when we look into the broad prospect, 6 boys plus 4 girls together should be 1. So 6 plus 1 is 7. That can be arranged in 7 factorial ways. So 7 factorial into 4 factorial. Next one. Okay, this is again, question is wrong. We can redraft it. 15C3R is equal to 15CR plus 3. Then what is R? So this we have to apply one of the concept. NCR is equal to NC N minus R. NCR is equal to NC N minus R. So that concept should be applied here.
R equal to 3.
R is equal to 3. Correct. So applying this NCR is equal to NCN minus R, we can say 15C3R is equal to 15C 15 minus R plus 3. Correct?
Yes, sir.
15. No. 15C3R is equal to 15C what?
15 minus 3R.
15 minus R minus 3. So can I say 3R is equal to 15 minus R minus 3? This can be equated. Then 3R, I'll send it this side. 4R will be equal to 12. 15 minus 3. So R equals 3. 12 divided by 4. The next one, again the question is wrong. NP4 is equal to 20 into NP2. So what is the value of N? What is the value of N? NP4 is N into N minus 1 into N minus 2 into N minus 3. 20 into NP2 is N into N minus 1. So I'll take out this. So N minus 2 into N minus 3 is 20. So N square minus 2N minus 3N plus 6 is equal to 20, or N square minus 5N minus 14 is equal to 20. Sorry, is equal to 0. Now further simplifying this, we get N is equal to 7 and N is equal to minus 2. 7 minus 2 is minus 5, correct? And 7 into minus 2 is minus 14. So 7 and minus 2. So N cannot be negative. N cannot be negative. Therefore, N is 7. Therefore, N is 7. Next one. How many different words can be formed with the letters of the word liberty?
7 factorial.
7 factorial. Yes. Which is? What is 7 factorial?
5040.
5040. 5040. That's all. So this is about permutation and combination. Simple. The questions would be simple. Very simple with regard to this chapter. Can I move on to the next discussion? Next one, again an easy topic, arithmetic progression and geometric progression, AP and GP. For that, we need to understand the concept of sequence and series first. What is sequence? Sequence is orderly collection of numbers in an order, which that order is based on some definite rule or law, some definite rule or law, right? So it could be even numbers, series of even numbers, odd numbers, based on a rule of law, squares, cubes, etc. Right? The nth term of a sequence is called the nth term of the sequence is called general term of the sequence. The sequence can be finite or infinite based on the number of elements that it has. Now, if the sequence is expressed as a sum of all the values of the element, that we call it series, an expression of the form A1 plus A2 plus A3 so on, which is the sum of the elements of the sequence, is called series. Again, based on the number of elements, finite or infinite series. Among series, we have arithmetic progression, geometric progression. When will we call that series or a sequence to be an arithmetic progression? When it has when the elements of the sequence has common difference. Right? Common difference. A2 minus A1 is equal to A3 minus A2. Therefore, we can say A plus C is equal to 2B or A plus B is equal to A plus C by 2 in case of arithmetic progression. B is called the arithmetic mean of A and C. How do we find out the nth term in case of an arithmetic progression? A plus N minus 1 into D, where A is the first element, N is the total number of elements, D is the common difference. D is the common difference. So sum of first, these are important. Sum of n terms of an AP, 2a plus n minus 1 into d into n by 2. First n term is n into n plus 1 by 2. We all know that. Sum of first n odd numbers, n square. Sum of first n natural numbers, n into sum of squares of first n natural numbers, n into n plus 1 into 2n plus 1 by 6. Sum of cubes of first n natural numbers is n into n plus 1 by 2 whole square. Okay, these we have to remember. Easy to remember. First n natural numbers is n into n plus 1 by 2. Cube is the square of it, n into n plus 1 by 2 whole square. Squares is n into n plus 1 into 2n plus 1 by 6. Okay, next, geometric progression. When we call a sequence to be in a geometric progression, when it has a common multiplier.
Ratio.
Yeah, ratio, common multiplier, correct. So in this case, sum of first n natural numbers depends on whether r, that is the common ratio, whether it is greater than 1 or less than 1. If r is greater than 1, sum of first n natural terms is a into 1 minus r to the power of n divided by 1 by r, 1 minus r. If it is less than 1, a into r to the power of n minus 1 divided by r minus 1. Whereas in case of an infinite GP series, sum is a divided by 1 minus r when r is greater than 1. These are important, can be asked in the exams. Okay, in case of geometric mean, since it has common ratio, we can say b square is equal to ac. Therefore, b is the geometric mean of a and c. B is the geometric mean of a and c. Clear with this?
Yes, sir.
Yes, sir.
Yes. So can we answer these questions? If x, y, and z are the terms in GP, then the terms x square plus y square, xy plus yz, y square plus z square are in which progression? So if x, y, z are in GP, can we say y square is equal to x into z? Yes. Then in these three terms, x square plus y square, instead of y square, I'll write x into z. This one. Instead of y square, I'll write x into z. Then xy plus yz. Then instead of y square, again, I'll write x into z plus z square. Now in the first, I'll take x is common, x plus z. In the second, I'll take y common, x plus z. In the third, I'll take z common, x plus z. So what are we having here? Common multiplier.
Common.
Yes, common ratio, x plus z. Therefore, it is in geometric mean. So geometric progression. So we can prove this also. Y square is equal to x into z, right? So this square, y into x plus z the whole square is equal to x into x plus z into z into x plus z. That should match. So y into x plus z the whole square, we have y square into x plus z the whole square is equal to x into x plus, this is x plus z into x plus z is x plus z the whole square. X into z is xz. Y square can also be written as xz. So xz into x plus z the whole square is equal to x plus z the whole square into xz. LHS is equal to RHS. Therefore, it satisfies the geometric mean condition, geometric progression condition. Therefore, this is in geometric progression. It is in GP. Then, in a GP, if fourth term is 3, then the product of first 7 terms. Fourth term. So, what are the series of GP? AR square, AR cube, AR to the power of 4, AR to the power of 5, and AR to the power of 6. These are the first 7 terms. Out of that, fourth term is 3. So AR cube is 3. Now what they require? Product of first 7 terms. So they require A into AR square into AR cube into AR to the power of 4 into AR to the power of 5 into AR to the power of 6. So how many A's we have? 1, 2, 3, 4, 5, 6, 7. A to the power of 7 are 1, 3, 6, 10, 15, 21. R to the power of 21. Though A to the power of 7 and R to the power of 31, can it also be written as AR cube to the power of 7? Right? A to the power of 7, R to the power of 21. AR cube to the power of 7. AR cube, we know it is 3. So, product of first 7 terms is 3 to the power of 7. 3 to the power of 7. Then, in a GP, if third term of a GP is 2 by 3, sixth term is 2 by 81. Then what is the first term? Third term is AR square. AR square is 2 by 3. Sixth term is AR to the power of 5, 2 by 81. Now, AR to the power of 5 can also be written as AR square into R cube, 2 by 81. AR square is 2 by 3. So, 2 by 3 into R cube is 2 by 81. Therefore, R cube is 2 by 81 into 3 by 2. 2 ones are 2 ones are, 3 ones are 3, 27s are. So, R cube is 1 by 27. Therefore, R is
1 by 3.
1 by 3. So if R is 1 by 3 in AR square, A into 1 by 9 is 2 by 3. Therefore, A is 2 by 3 into 9. 3 ones are 3 threes are. A is 6. A is equal to 6 is the answer. Okay, next one, last one. Sum up to infinity series. 1 by 2 plus 1 by 3 square plus 1 by 2 cube plus 1 by 3 to the power of 4 plus 1 by 2 to the power of 5. So it's not continuous. One is 1 by 2, second one is 1 by 3 series. So how can we solve this? Splitting this. Split this 1 by 2 plus 1 by 2 cube plus 1 by 2 to the power of 5, so on. One set plus 1 by 3 square plus 1 by 3 to the power of 4, so on. Now, if it is 1 by 2, 1 by 2 cube, 1 by 2 to the power 5, whether it is in arithmetic progression or geometric progression?
Geometric progression.
Geometric progression, we have common ratio, right? What is the common ratio? 1 by 2 square. Here R is 1 by 2 square, A is 1 by 2. I want infinity, sum of infinity terms in case of a GP formula, A divided by
1 minus R.
1 minus R. So here A is 1 by 2 divided by 1 minus R is 1 by 2 square, which is 4. So solving this, we get 1 by 2 divided by 4 minus 1, which is 1 by 2 divided by 3 by 4, or 1 by 2 into 4 by 3. 2 ones are, 2 twos are. So 2 by 3 is the sum of this series. Similarly, can I calculate this? What is A here? Again, is this in GP? 3 square, 3 to the power of 4, 3 to the power of 6 and so on? Yes. So A is 1 by 3 square. What is R?
1 by 3 square.
1 by 3 square only. R is also 1 by 3 square. So sum of sum of infinite series is A by 1 minus R. So 1 by 3 square is 9 divided by 1 minus 1 by 9. 1 by 9 divided by 8 by 9. 1 minus 1 by 9 is 8 by 9. 1 by 9 into 9 by 8. 9 gets knocked off, 1 divided by 8. So sum of this series is 1 divided by 8. If I want to get the total, what I have to do? Add or multiply? 2 by 3 plus or 1 by 8 or 2 by 3 into 1 by 8? Add because these are sum, right? So we have to add. So we get 24. 8 twos are 16. 3. 19 by 24. 19 by 24 is the answer. Okay. So such kind of problems we have to split the series and then get the answer. So these are the questions that have been asked. So we are done with 34 questions. We're only left with 6. That is set, relation and function and calculus. So set, relation, function, obviously we'll not go in detail. We'll just look into those concepts which we can easily understand. Okay, some concepts are a little difficult. The functions related and relations and functions, it's a little complicated. So we'll not look into that. Sets, we have already discussed this in probability statistics, right? But some small discussions. If a set contains only one element, we call it singleton set. Two sets A and B are said to be equal if every element of A is in B. So if A is equal to 1, 2, 3 and B is equal to 1, 2, 3, will I call it equal sets? Will I call it equal sets?
Yes.
Yes, we call them equal sets. But if B is equal to 4, 5, 6, will I call it equal sets?
No, sir.
No. But we can call it equivalent sets. Right? When we call it equivalent, the number of elements of set A is equal to number of elements of set B. Then we call it equivalent sets. Right? Then if the set contains all the elements given under consideration, we call it universal set. And collection of all possible subset of a given set is called power set, P of A, denoted by P of A. A set contains 2 to the power of n number of subsets, 2 to the power of n minus 1 number of proper subsets. Proper subsets means excluding the sample space. Okay, so this is the concept of sets. It can be represented in form of a Venn diagram. So here in case of Venn diagram, we all know this union, the middle part, intersection, etc. The common points that we have already discussed in probability. Okay, then we have something called product set, ordered pair and Cartesian products of sets. Two sets A and B listed in a specific order form an ordered pair. That is, let's say A is A, B and C, B is D, E and F. Now, what are the ordered sets, that ordered pair that we get? A into B is AD, AE, AF, right? These are the ordered pairs that we have, AD, BE, CF. So these are called ordered pairs. If I get the product of them in a single set, then we call it Cartesian products of the set. Cartesian products of the sets. Okay, then we have relations and functions. With regard to that, we have multiple functions: one-to-one function, bijection function, identity function, into function, constant function, equal function, inverse function, etc. Just to go through the definition, okay, in case they ask theory question with regard to that, just go through the definition of those functions. Similarly, we have relation, reflexive relation, symmetric relation, transitive relation. Reflexive, symmetric and transitive relation. What are those? Simple. What is reflexive means? If it contains same order, A and A, we call it reflexive. If A, B is one relation, BA is also the same. If BA relationship also holds good, then we call it symmetric. If AB is a relation, BC is another relation, and AC is also a relation, then we call it transitive. If it is all reflexive, symmetric and transitive, we call it equivalence relation. We call it equivalence relation. These are the 4 types of relations that we have. Okay, that's all. These are the concepts that's there in sets, relations and functions. With regard to relations and functions, if you have time, then go through those definitions of different types of functions. Okay, else don't worry about it. In case it comes in the examination, 1 question or 2 questions maximum with regard to the functions related. Right? Sets 2 to 3 questions would be asked, out of which 1 or 2 questions would be easy. The other obviously would be difficult. So it's okay. Even if the understanding that question, again, we cannot break our heads at this point in time in understanding those concepts. Same applies to calculus also. In calculus also, there are some formulas which are easy. Okay, go through those formulas, remember those formulas. If those formulas related, obviously will be asked in the examination. Just the application of the formula and getting the answer also will be asked. Okay, 1 or 2 questions will be asked in that sense also. So we can easily score there. What we have to do is just remember those formulas, solve some questions in the study material. That's all. Don't go in detail. What is differentiation? What is integration? Don't break your head. Differentiation is using the derivative. We are identifying the relationship of one variable, change in one variable with regard to change in the other variable. Right? That is differentiation. Opposite of it is integration. Opposite of it is integration. So with regard to differentiation, we have various formulas, right? These standard formulas. Remember these standard formulas. X to the power of n, derivative of x to the power of n is n into x to the power of n minus 1. Derivative of e to the power of x is e to the power of x only. Derivative of a to the power of x is a to the power of x log of a to the base e. Derivative of any constant is 0. If they ask derivative of 5, it is 0. derivative of any constant. Derivative of e to the power of ax is a into e to the power of ax. Derivative of log x is 1 by x. Right? So similarly, these, if you remember these things, straightforward questions will be asked in the exams. We have to just apply. They'll give you derivative of let's say they can give you derivative of 2 to the power of 3 or x to the power of 3 minus 5. In such case, what we have to apply? We have to apply these two. X to the power of n's derivative is
3x square.
3x square. 5's
Minus
derivative
0.
is 0. So minus 0. The answer is 3x square. Simple. Right? So remember these formula. Apart from that, these are properties. In logs also we have discussed this. See, if we have a function of h of x is equal to c into f of x, its derivative would be c into derivative of f of x. Since we are multiplying a constant c into f of x, so its derivative would be calculate the derivative of f of x multiplied with c into derivative of f of x. If h of x is equal to f of x plus or minus g of x, in such case derivative of f of x plus or minus derivative of g of x. H of x is product of two functions, f of x into g of x. In such case, you have to calculate first derivative of g of x multiplied with f of x plus derivative of f of x multiplied with g of x. Then if it is quotient, f of x by g of x, in such cases, first derivative of f of x multiplied with g of x minus, since it is quotient, minus derivative of g of x multiplied with f of x divided by g of x the whole square. Then if it is function of a function, f of g of x, in such case, you will have to calculate two derivatives. One, derivative of f of z. What is f of z? G of x. So function of g of x derivative should be calculated, and then derivative of z should be calculated, dz dk. Okay, these are some of the laws that we have to keep in mind. Okay, sometimes straightforward questions can also be asked, not application based. They'll give you this, identify the derivative of that. Just identification can be a simple calculus. They'll not give you complicated questions. Simple questions will be given, but there are multiple concepts there where we get confused. So we should not get confused. We should keep it simple. Only these concepts we should focus on, and we should learn this, and we should apply that. Okay, these are all not required. Parametric equation, logarithmic difference. So you calculation of differentiation using logarithm is logarithmic differentiation. That's all. Okay, then where do we apply this? In case of rate of change in quantities, we apply differentiation. And in case of cost function, this is important. In case of cost function, variable cost, fixed cost, etc., we use the concept of differentiation. Now cost, total cost, we can divide it into variable cost and fixed cost. You will learn this more in detail in intermediate. Okay, what is variable cost and fixed cost? Fixed cost is unavoidable cost. Variable cost is changes over the production. So purchase is a variable cost. If I have to produce, I will purchase. But salary for an employee is fixed cost. Because since I have employed him, whether I do business or not, I have to pay salary to him. Right? So variable costs are denoted by V of X, fixed costs are denoted by F of X. So the relationship total cost of C of X is equal to variable cost plus fixed cost. Where do we use this? If I have to calculate average cost would be total cost by output, C of X divided by X. Average cost per unit. See, if the total cost is 10,000, number of units produced is 100. What is cost per unit? 10,000 by 100. Correct? 10,000 by 100. Total cost is 10,000. Number of units produced is 100. So cost per unit is 10,000 by 100.
Yes, sir.
That is what we are doing, average cost. Similarly, average variable cost would be out of 10,000, let's say 6,000 is variable cost, 4,000 is fixed cost, 6,000 by 100 is average variable cost, 4,000 by 100 is average fixed cost. So this, using derivatives, we can calculate this marginal cost. Okay, what is marginal cost? Total, if C of X is the total cost producing X units, increase in the cost in producing one additional unit is called marginal cost. Now, if 10,000 is the total cost for producing 100 units, if I have to produce 101 units, let's say I have to spend 10,050 rupees. Then this 50 rupees is called marginal cost. For producing one additional cost, one additional product, what is the cost incurred, additional cost? That is called marginal cost. Marginal cost can be calculated using this derivatives principle. Okay, derivatives principle, there is a formula. Rate of change in C per unit change in output and output level of X units. So why we can apply derivative is because derivative helps us in identifying the change in the value of X for every change in Y. Correct? Dx by dy, derivatives. So same, change in the total cost for every change in the unit is marginal cost. So they can ask this kind of a question, marginal cost, which is the cost which can be calculated using the concept of derivatives. They can give you average cost, fixed cost, total cost, variable cost, marginal cost. So we have to select marginal cost. We have to select marginal cost. Fairly understood? Integration,
Yes.
reverse of differentiation, again go through this formula. That's all. Remember these formulas. The integration of x to the power of n is x to the power of n minus 1 divided by n plus 1 plus c. C is the constant. So in every integration formula, at the end we'll have plus c, the constant, right? So go through these formulas. Apart from that, we have some other additional formulas. If possible, remember, this is the basic formulas. This we have to remember, basic formula. Apart from that, some standard formulas are there. If possible, well and good. Remember, else no problem. Calculus, don't worry about. Okay, don't break your head with regard to calculus. These are the properties again. See, f of x, d of x. If I have BA, if I want minus of it, then it would be minus AB, f of x, d of x. One of the properties of derivative integration. So these are f of x. Integration of f of x will also be equal to f of t if the variable is t. If the variable is x, it is f of x. Variable is t, f of t. Okay. So with regard to sets, functions, and relations, and in calculus, integration and differentiation, just go through the basic concepts. Remember the basic formulas. Straightforward questions you can answer. However, those who are already prepared with regard to sets, relations, functions, calculus, please go through whatever you have prepared. Those who are not yet prepared, those who are not so confident with those topics, don't break your head with regard to those topics. Mathematics, if you are not confident with sets, relations, and functions and calculus, focus on the first 6 chapters. First 6 chapters, we can score 20 to 25 marks easily. Is that clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes. Okay. Now with this, we are fairly covered the syllabus, fairly covered. Obviously, we cannot go in detail. We have fairly covered what is required to get 60 plus. We have covered. Now, what we have to do is prepare. We have to put in our efforts. So whatever we have discussed, build upon that. Okay. Obviously, what we have discussed in the class, going and writing in the exam, it doesn't work. You have to prepare. You have to solve some more problems so that you'll be more confident. Okay.
Yes,
Now,
sir.
fairly confident with regard to the approach.
Yes, sir.
Yes, sir.
Yes.
Yes,
Yes,
sir.
sir.
Yes. See, one point that we have to keep in mind is we should not panic. Okay. Specifically this subject, because in this subject, unless our mind is free, we cannot get the answers. We cannot get the next step, right? If we are panicking, our mind goes blank. The next step will definitely not get, even though we are knowing it. So whatever the questions are, however standard the questions are, don't panic in the exams. Okay, just keep yourselves calm. Read the question again and again. If you read it twice, thrice, it'll happen. At the end of the day, you will have on an average 1.2 minutes per question. So some questions would be easy, wherein you can finish it quickly. The other questions you can afford to take some time. So accordingly, we can plan and we can answer the paper. Clear? Anyone has any specific doubts, not related technical aspect, generic doubts? Yeah, thank you, Mehak. No? Fine then. Okay. Just go prepare yourselves for the next. We have 3-4 days, right? Prepare, put in all your efforts. It will happen. Nothing to worry about. Maths and stats. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you
Thank you,
so much, sir.
Thank you so much, sir.